right, how's everyone doing today? Welcome to another episode of Mastermind Academy. Just getting set up here, running a bit late, but we're all good. Only a minute, not bad at all. What's up, Ain't No Profit? Yeah, welcome. It's good to see you. What's up, Lele? How are you doing today? Happy Tuesday. Keep thinking it's Wednesday. I really do wish it would be Wednesday. What's up, Penguin Airlines? Good to see you, VA. Good to see you, Sully. Yo, how you doing today? I hope you're doing well. Ain't No Profit about to get caught up on the VODs. Yep, everything is up to date on there except for yesterday's video, but it is uploaded. It'll go live right after this. Today it's already in YouTube process and everything. So yeah, all good. Take your time, no big deal. Pick up what you want tonight. You can always work backwards. It's all good. Hellfire, good to see you. Why? Hikaroshi, how you doing tonight? It's good to see you. So tonight, we are in, this starts week 3 of our journey into software engineering and computer science. And tonight we're gonna be covering some primitive data types, some more primitive data types. These are data structures. You'll hear them referred to as both. We'll talk about that a little bit. So we're gonna be covering collections. We've already dove into it a little bit, but we'll be diving into it deeper, spending some time. Then we will be going into starting to learn some of the logic of coding. We did do a crash course in this yesterday in Python. If you were here, you will have a leg up into going into these things, but we'll spend more time on each thing. We'll do more examples. We'll talk deeper about what's happening under the hood when these things are going on. C. Sanchez had a nightmare and I was involved. Well, I'm sorry that I was involved unless I was trying to save everyone from whatever bad thing was happening. Now, if I was the monster, I get it. It's okay. I'm okay with that. I just hope that I was a cool monster. I love to hear about it. I hope I was in the dream in a good way, since I was involved and not. Hopefully, it wasn't the reason why that made it a nightmare. But if it is what it is. Oh, you saved me. Thank you. I appreciate you. See, that's love right there. Thank you so much. You saved me. I appreciate that. I won't forget it. I'll never forget it. I am now indebted to you. All right, so I'll have to make sure to also save you one day as well. You ever talk about the benefits of using a Lino server besides for just this course? Oh, I didn't, but we can, let's go. We can talk about that for a little bit. Hello from Guadalajara. Dope. That's super cool. Good to see you today. It's good to see you as well. Yeah, so I had a bunch of issues with quiz. It's super weird because we were on here and we changed some stuff. We changed the permissions. People were able to get in, but I also got requests for pipelines quizzes last night to be opened up. It was really weird. And like the settings were already right, but then I refresh everything, and so far everything seems good. I did the same thing to deCoded earlier this morning, so you should be good for everyone deCoded. The quiz is in there. Take your time with it. Not a big deal. Someone also asked, you should be able to retake it now as well. Let me know if you're having any issues retaking it if you want. If you need to retake it, you should be good to go there now. Besides that, I feel like I had something for you all. I feel like I had something to tell you, something to talk about, but I don't. So we'll just talk about the benefits of a Lino server. So one, the reason why we talked about a little bit in the beginning about why I was using a Lino server. They are a channel sponsor, be very transparent, but I did start using it in the way that I use it is not, they've never instructed me on any way to use their product. They just kind of want to be a part of the community. And I used it again because I use many different computers. I work off of 3 different computers pretty daily. I touch 3 different computers daily that I actually do development from. And so I set it up as kind of just a remote place because I saw that you could do SSH tunneling in VS Code. That's what I use it for. But what else can you use it for? You can use it for anything. You can use it for file storage. It wouldn't be the best option for file storage, but it's good. I like to have a remote computer that's networked to be able to do things on the internet. Like we're learning how to code, we're learning how to manage systems, all that other stuff. I like to have an already networked system that allows me to do some cool things like this, to be able to have a sandbox for setting up websites, for setting up web applications, for running all kinds of servers and services. I run a Rocket Chat out of my VPS. I have all kinds of, I host other people's websites out of my systems, my cloud systems. But yeah, I find a lot of value in having you can do a lot of these things locally, but the problem is you have to deal with things like IP address changes, and you don't have the flexibility to serve out to many people. So if for any project or for any messing around. Again, I also use one as a kind of a backup environment as well. I do still do development things locally because I do have a pretty powerful computer, so sometimes I need a little more processing than I get with my Lino server. But yeah, I mean, really just to practice and to play with all the tools that are out here, especially if you live in an area of a low bandwidth, if you don't have really fast internet. It's another big reason why I recommend checking out Lino or one of the cloud providers for a cheap VPS, because when you need to download things, especially when we get into stuff like Docker and where images might be a problem, for uploads especially, when you need to upload a Docker image, my internet is kind of trash for uploads, and it used to cause some problems for work when we had one image in particular that was like it was almost 2 gigs in size. I know it sounds crazy. It was Drupal. There was no way around it. There was actually no way around it, and it was super problematic if we had to build locally, which happened a few times. Super trash. But yeah. Did you do DevOps? I did. I have a college question for multiple choice question, and I don't know what to pick. Ask away. We'll see if we can help out a little bit. But yes, I've done DevOps for many years. I've led development teams, worked with infrastructure a lot, for sure. Yeah, exactly. Dev, no, 100%. It was only one image. We hated building it, and we always had a problem with it during emergencies because it was so large. Our CI process through Circle had issues sometimes as well. So sometimes we had to build locally and push locally, and it would take so long because whenever there was an issue with the service, like it was critical. It would take so long to upload. It was so trash. It was the worst, like really terrible. Okay, so let's actually check this out. Hold on real quick. I'm gonna pull this up on screen. We'll go into this. Luckily tonight is not a, I don't think tonight is crazy heavy at all. I think we should have time. So I'll run through this question in a second. I should be logged in here. Let me click this. Let me get logged into the chat here so I can get that question pulled up on this system really quick. Let me just grab my 2-factor auth. If you're not using 2-factor auth, I know it's annoying sometimes, but you really should be using 2-factor auth. 2, 3, 4, 8, 9. And no, I'm not giving you my password. It's all good. I'm not. Oh, okay. So I can't. Oh no, wait. 29. Oh no, 281. Oh, I messed that all the way up. See, I have to hold on for a sec. Oh, never mind. You guys can't see this is great. I was worried about showing you all 2 of my codes in a row because that can be problematic, but you can't see my screen, which is phenomenal. So this is good. Let me go ahead and click this link here and let's check this out. Yeah, BPaz, you can retake it. I also fixed some of the answers. There were 2 of the answers that were wrong, or weren't in there at all. And so I fixed those, so you can retake it if you need to. So we got a question here. In a commercial software environment, what is it appropriate to deploy a build to an environment? This is a good question. So just a little context for everyone who's not interested in DevOps or systems. This is a good question because you all are learning software right now, and this is a very yes, it's a infrastructure DevOps, like a pipeline related question, a workflow related question, but this is talking about building the software that we are learning how to write. So hey, when software code has been fully tested, the release of a new build has been approved, and the environment has been cleaned up. That seems like a good answer. That seems like the answer, but let's read the other ones. When the software code and associated materials has been fully tested in the live environment, nope, that's already wrong. The very first thing that they say right in front, you don't want to test. Well, it says in the live environment, and the release of the new build to system test has been approved. I don't know. When they say live system, I'm assuming they mean production, but let's see, has been fully tested. The release to, okay. I think that's fine. When the software code associated materials has been fully tested in earlier environments and the release of the new build has been approved. This is pretty good, but this says to an environment. It doesn't say to production. It says to an environment. So I don't think this one in particular is special. Associated material code has been refactored, optimized. No, not this one at all. Especially when you're talking about in terms of DevOps and everything. You know, you're not waiting until things are perfect. You're waiting. You want to push things out. You want to be able to get feedback on it, gather feedback, make improvements, iterate over it, and keep releasing. Code requirements, text, and refactor to optimize performance now. When software code materials been prepared, developers, and they say it's ready for deployment now. Yeah, I think this top one is. I think it looks good. I think that's the best answer out of all of these. I think this one could also be a good answer, but actually, materials been tested in early environments. Yeah, but like right here, it says to an environment rather than production. And maybe if they said to the production environment, maybe this one will be more fitting. But yeah, yep. I think this one is. See, the only thing that throws me off here is the environment has been cleaned up, but I think that's fine. I think that makes the most sense for this. But yeah, keep throwing out questions. I like stuff like this, and kind of analyzing stuff like this. But yeah, I think you got a spot on there. All right, so let's go ahead and let's hop into our slides for today, so we can go ahead and learn what we need to learn today. Yes, you should test before you deploy. Yeah, one of them did say testing. It said test on a live server. Again, I don't know their terminology. I assume when I first read it said live server. To me that means production, to be honest. But I guess all of your other environments could be live servers as well. Aban, those are, I'm going to delete that command right now. The classroom command that's old and it's incorrect. Do !register if you want to. You gotta put in your email. Actually, well, I can show you this classroom code right now though. But if you want all the classrooms for all the things, do !register. But I will give you the classroom code for this right now if you want to grab it. And we're gonna go check out some classwork. You do have a GitHub Classroom assignment. This is so there you will run into issues with GitHub Classroom, well, GitHub Actions right now. I don't know if it's just me, but I think it's having problems. I did resolve my major problems with a lot of the other ones. Some of the decoded ones need to be updated with those fixes. So you may get some errors when you run it. Maybe you might be fine. I think you'll be fine. There might be one that might give you some trouble because it's doing some weird stuff with a regular expression. So that one's probably my fault, but we'll see. You should be able to go through and click the link and it should walk you through what you need to do with that. But let's go ahead and click on this. Cool. So here we go. You made it to week 3. We are 5 of 16. We're moving through. We're getting comfortable. But again, tonight is really fun because tonight is the first time we're going to touch some logic. First time we're going to see, we're going to make some decisions in our application and understand how that process works. This is when coding gets powerful, but we need to dive into some deeper concepts. Again, we're still going to keep it. We're going to keep it relatively light, but we are going to talk. We are going to talk deeper about these things than we've talked definitely than we talked yesterday, for sure. But we're trying to make it as practical as possible. So here's the agenda. Collections first, and so I put collections here again because we're going to talk about you're really learning your first data structures, or these are also these data structures are considered to be data types. They're considered to be primitive data types in these languages, but they are structures of data. So we're going to learn about those. We'll learn about 3 of them in both Go and Python. Then we have arithmetic operators. Big word, it's just math. We're just going to talk about basic math. We learned a little bit about strings last week. We'll learn how to work with numbers a little bit. We'll also see how numbers work, these arithmetic operators, how it works with other data types as well. We will do comparison operators, so you'll learn how to compare values and what that determines. And then we'll talk about control flow. So yeah, yes, Devno, you got it. You got loops. She's definitely on Wild True. She's gonna keep going. We'll spend a lot of time with loops on Thursday, and combining all of these things together, because this is honestly, like this, what we're learning this week is kind of the minus the math. It's the part that you're going to be doing a lot. You're going to be doing this stuff a lot. So we're going to need to spend some time, especially when we get to loops, practicing these things. So let's get started. Let's talk about our primitive data structures. And all we mean when we say primitive data types, or you see primitive data structures, these are data types and structures of data that are available to you directly in the language, ones that you don't have to go out and create yourself. Usually when you hear the word data structures, it can be kind of scary. People are talking about, oh, I got to do some algorithmic problem solving. I got to learn data structures and algorithms and stuff. And usually that is referring to having to create these structures of data yourself using different paradigms in each language. These are data structures that are built in, and again, they're considered to be data types in these languages as well. So yeah, so first one is arrays. Okay, this is a big one, and this one is one that I find to be confusing for a lot of people. Not when you learn it, but usually when everyone has learned this in another language, when this is not your first time seeing it, this can be a little bit of a confusing topic. But arrays are simply structures of data, and they consist of a collection of elements. So we talked about that a little bit. And they can be identified by their index. So we talked about indexing a little bit. We're gonna dive way deeper into indexes tonight. Indexes is its place in the collection. These collections are zero indexed, okay? we looked it up before, there are not very many languages that are not zero indexed, but Go and Python are both zero indexed. So that means their placement starts at the number 0 and goes up from there, 0, 1, 2, 3, 4. So if you have something with 5 elements, the index starts at 0. The first item is in index 0 and goes to 4. Arrays are fixed in their size. They are a fixed size as well as the data type that they hold. This is an important one. If you're coming from JavaScript, if you're coming from Python, I think if you're coming from Ruby as well, you may be like, that's not what I know to be true about arrays. That is because you are not actually using arrays, but we're gonna dive into that. Arrays are fixed in their size and what data type they can hold, and we're gonna talk about why they are fixed in their size and what data type they can hold. Okay, so let's hop in and let's start doing some code. Let me get you the slide link. Sorry, I forgot to share that. And I forgot to update the command. 20 minutes late. Well, we're just getting started. We haven't written any code yet. We haven't done any of that yet, but we're definitely gonna get there. Let's see, commands, edit. Move this. All right, cool. Now it should be there. During Paleolithic tally sticks, of wood, bone, ancient times, data recording. Paleolithic tally sticks. That's the best kind of tally sticks. Feel free to answer whenever you are. I'm also stuck on this. Feel free to get her. Okay, I'll pull it up just so I have it here, and we'll hop into it in a little bit. Yeah, exactly. You are 20 minutes on time. Exactly. All right, so let's take a look at these arrays. Let's get signed into our server. Actually, nope, I'm not gonna do it through Vim. I keep forgetting that I am now a VS Code user for you all. Well, for me too. I am really liking it. What's my password? That is not my password. I almost sent you all my password, but I didn't. Maybe it's that. Nope. Maybe it's that. All right, cool. So this is all the Python stuff that we did last night. Let's move into the correct directory. I really need to set up my SSH keys on this machine, but it never feels like it's the right time. So maybe at the end of today, we can talk about SSH keys here, and I can show you some cool stuff. But let's go back. Where are we? And this is decoded, and cool. Here we go. I typed my password in the Twitch chat before, and that was a pain. Yep, I have also done it as well. Haven't done it in a really long time though. I typed that. That was the third time I just typed my password wrong, though. I'll tell you that right now. There we go. That felt right. What? Close remotes. No. What just happened? This not it? Hold on. But I'm logging over here. So this is the one big problem I don't like about the VS Code SSH tunneling. If you open up a new folder, it opens up in a completely different window, and you got to log back in every single time. That's why I need to get my key set up. All right, I was just typing in the wrong password, so yeah. Could you explain how to get Linux on Windows? Good question. The way that you get Linux on Windows, if you are running Windows 10 and you are on an up-to-date build, you can get this. Yep, WSL2, and it's pretty simple to install. They'll give you 2 PowerShell commands to run. You run both of those. You restart your computer, and then you go to the Microsoft Store and install the distribution, like Ubuntu. I use Ubuntu. There are other ones in here as well. There's OpenSUSE. I think you can just type in like Linux, and it'll show you all the distributions it has, which isn't many, to be honest. They have Kali Linux. They have SUSE. And then I think there's like a paid, so there's Debian. There's also like a paid version of Fedora in here or something, which I wouldn't get, but there are, you can follow that guide, and it's a pretty simple process to get it installed. All right, so now that we are in a place that we want to be, week 2, let's make a new folder. I'll call it not inside of week 2. Come on, don't do that to me. Why does it keep putting it inside of? I'll just make it here. I will make it right here. You know, no need to use the GUI when you can use the command line. I had a problem with Windows Store, so couldn't install Linux. Oh, that sucks. Yeah, I don't actually know any other way to do it, to be honest. That's kind of weird. So let's make a directory real quick. Week 3. And we should be able to see that over here. And what we're gonna do first is we're gonna do O1, and we're gonna do arrays.go. Actually, let's make folders for each of these things. Actually, it might make it a little bit easier to go through, especially since we are doing, let's make a Go folder, and let's make a Python folder as well. I think this will help us out a little bit. And in the Go folder, we are gonna, oh, whoops. Yeah, I'm not doing this from over here. I wanted to do it over here so like it could be more easily seen, but let's go into week 3 and mkdir Python, and then we will operate accordingly in both of these folders, and we will create the code for each of these in each folder. So in the Go one, I'm gonna make an O1 arrays.go, and let's go ahead and let's talk about this. VMware local VMware. So I do like VirtualBox as well, you know, VirtualBox, or you can do the SSH tunneling. That's one of the biggest reasons why I put that out there, is because out of all the options, I do think it's one of the simpler options. To be honest, like if you don't want to mess around with all that stuff, but I do think it's valuable to kind of learn all that stuff as well. But okay, let's do this. So arrays in Go, let's set up our Go file. So let's just, good practice and good muscle memory to set it up like this. We're gonna set up our function called main. There we go. We have the structure, everything needed to run our Go code right here, ready to go. And let's talk about arrays. Remember, arrays are a collection of elements. They are of fixed size, and they are of a fixed data type. So there are, so let's go ahead and make our first collection. We've kind of seen the collection a little bit, but let's go ahead and set that up. Our first array. Okay, and our first array, we'll just call it X. All right, and we'll do it shorthand here. And so we're gonna set it equal to, and this is gonna be the first time you see something like this, but a collection, brackets kind of denotes a collection of different things. So that's the first thing you need to put down here. But we're gonna type in first, the data type that is going to be stored in this collection, okay? We're gonna need to determine what we wanna store in it. So if we wanna store a bunch of numbers in it, we can store some integers in it. If we wanna store some strings in it, we can store some strings, decimals, floats, whatever we need to store. We can store Boolean values. And so let's start out with some numbers. So we can say, hey, we want to store a collection of integers. This is the data type, and we can put it in here like this, and we can start to put the things that we wanna put. So 5, separated by commas, 10, 74, 0, 1, comma, a large number like this. All right. Now, what we actually have here is something we're about to learn in a second. This is actually a slice. This is actually not, it is an array still, but this is not yet an array. Remember I said an array is a fixed size. So right now, this would work. This code would work. I mean, I would need to use X, but this code would work, but it is not, it wouldn't be how you specify an array. An array is a fixed size. So let's say I wanted to set a fixed size, 1, 2, 3, 4, 5, 6 items in here. So array size 6. Why are we specifying an amount? The way arrays work is when you specify an array like this, it needs to set up a space in memory, and it needs to set up that space in your memory. So remember, we're talking about RAM. It needs to take up what's called a memory address, and we'll dive deeper into memory addresses later, and we're going to learn about pointers and all that other stuff. But it needs to take up some space in memory. It needs to reserve some space in memory, and that space needs to be adjacent to each other. So it needs to know in the beginning how much to carve out, because let's say you fill up an array and it needs to add an item to that array. There's no guarantee that the next memory space over, if you don't reserve it, there's no guarantee that it'll be available. And so it doesn't quite work unless you specify how many things are going to be in it. And so let's just take a look at this, and I'm going to simply format.println. Whoa, what was that? Let's just simply print out X and just see what this looks like. Okay, so it went ahead. You saw it auto format for me. Remember, Go has auto formatting. And let's CD into Go right now. And let's go run O1 arrays.go. And we essentially get a printout of exactly what we have, but it's in brackets. And that, again, that denotes a collection. Whenever you see that, think array, think collection whenever you see these brackets printed out like this, okay? Do they support the old C way of doing type? I don't know. I can go by example. I only ever specify one. I never use arrays. Never. I've never used an array in production code, and I'll show you why when we get to slices. But let's see. Let's see if that works. Let's see. Well, it would probably, to shorthand it, that probably wouldn't work. I don't think that would work, but we can try it in a second. There's also go by example as well, and we could also see if they usually show you a couple different ways on go by example. Again, this is why it's a really good site to look for syntax. Separate syntax in your mind from the concepts that we're learning, but these language by example sites are a really good place to quickly go see these things. And so if we look at an array, we can see some different ways. So we could do the basic way of declaring a function. We could declare this variable X or whatever and tell it we're going to have, so this one is declaring a variable called A, and it is saying, hey, I want to set up a space for 5 integers. The data type is integers, and we can set it up that way. I don't see the way that that you have it. This is the kind of common way. The shorthand is pretty common, but yeah. Any practical applications where you use arrays versus slices? Yeah, yes. We'll get into that, but I because of slices, I don't think there is. And again, I'm not a Go performance expert, but as from the things that I know, the way that they work, I don't see any reason to use an array, because if you need specific sizing functionality, slices have that as well. But we're going to talk about that for sure. So yeah, so a couple different ways to do it. Again, go by example is good. It's good to see this with, but this is what we have here, and so that's great. And so we can't have more than the items that are in here. So if I go ahead and I try to add another number in here, try to add one more item, will that work? We already see that there's a problem, and it says, hey, array index 6 is out of bounds. You said you were only going to have 5 items in there, or 6 items in there. You're like, that's all you're supposed to have. But now you have 7 items in there. So it will not allow us to do this. There must be that many. But what if we remove one? Can we have 5 items or even 4 items? Can we only have 4 items in here? We said save space for 6. Can we have 4 items? Yes, we can have, we can declare or assign value to 4 items, but notice what prints out. Check out what prints out right there. There's still 6 items here. 1, 2, 3, 4, 5, and 6. The last two items are simply zero value. So yes, you don't have to fill up the spaces, but Go will in turn assign those spaces a zero value, because again, you told it 6 spots, it will give it the zero value of the data type. So if it's a string, it will put an empty string in that slot. If it is a Boolean, false will go in those slots. Okay, so whatever the zero value is, we'll put that in there. Okay, so great, super exciting, amazing. What if you wanted to add something to an array? Maybe you had an incomplete array, or you wanted to add something to it. What's funny is, I'm assuming that I can do this because, well, yeah, I've actually never appended to an actual array in Go because I don't use actual arrays in Go. But let's see if this works. I actually want to see what happens here. It should work. There should be no reason why it doesn't work, because slices are just arrays, but it's just a different interface for it. But let's see if you want to add something to an array, because it is something that you might want to do. Add item to array. There's usually a couple different ways you can do it. Actually, before we add an item to array, let's talk about selecting an item in array, or selecting item in. Actually, let's do this part. Let's move on to slices, and let's do this part, because with slices we can both talk about slices. We'll also talk about lists when we do slices. So let's not do this piece in arrays, because it'll be they are very similar. They're really the same thing, but yeah, let's do that. So we'll leave this here as an array. Python's not going to get an array. Python does have arrays, okay? But Python arrays work a little different, and they come in a separate package. They come in like a PyNum package or something like that. People don't really use arrays in Pythons. Data scientists do, but an array as it really exists, it's not a data type in Python. It's not. Arrays don't work in that way by default in Python. Python use lists, and that's why we're going to move over to this next slide, which is slices, and we'll talk about all that here. Okay, slices and lists. So slices is for Go, lists is for Python. We'll make that clear. But most of the time, we have no idea the exact number or the exact amount of things we want in a collection. This is where slices come in. A slice is simply a better interface for an array. So it's simply like a little top layer over an array to do to make it easier to work with. Because if you wanted to make an array larger, remember I said it needs to save some space in memory. So if you want to make it larger, it can't just take the next memory space over, because it doesn't know if that space is available. That space might not be available. So if you were to try to make a new array, if you wanted to extend an array, what you would need to do is make a new array, take all the data out of the old array, copy it into the new array, and then delete the old array. That is the amount of work that you need to do. We can do that in a couple lines of code, but that is a very annoying thing to have to manage over and over again in your code. It can be super problematic, or it can be just super annoying to deal with. Slices is an interface on top of arrays to allow for some cool things. It allows for the dynamic. It gives it aspects of a dynamic array. So dynamic arrays are a thing in some languages, and this gives it dynamic array properties, and so it allows the array to shrink and to grow as needed. It works in a very interesting way, but you also can still have the good pieces of an actual array. Like, one of the good things about an array is that you can specify size, and so that if you know exactly what you need and you tell the computer to only use exactly what you need, that is more efficient on the computer. That is a more efficient runtime. And so that is a capability of slices, okay? Slices, right up front, the first thing I want you to think is that slices allow you to make arrays of unlimited size or unknown size, okay? The way that we make a slice, first off, is to basically remove that number from inside of the brackets, and that will make a slice first. But I'll show you how that works. And so there are going to be times when, this is a collection of data. So there are going to be times when you're processing things in your code, and you are keeping values. You want to store up values, and you want to say, hey, I want to keep track of things that are going on in this program. And you might be putting things into this collection, and you may not know how many times it's going to run. You may not know any of that stuff. So a slice might be what you want to use for this. But again, I use slices all the time. I never ever use an array, but it is the same thing in Go, at least. Python, on the other hand, has a similar functionality. It has a collection functionality, and it's called lists. So it has a couple of, both languages have a couple different types of collection functionalities. The list is most like an array in Python, but the difference is it can have unlimited values. It can be any number of values. It's not a fixed size basically. And the weird thing about it is that it can handle any combination of data types. So it doesn't have to be all one data type. It can be, you can throw some integers in there, you can throw some strings in there, you can throw some Boolean values in there, you can throw some floats in there, you can even throw other lists in there, okay? So that's kind of the difference here, whereas you cannot do that in Go or most compiled statically typed languages. So let's see what that looks like here, and then we can also see what lists look like in Python right now. What's up, Lord Azazel? I am doing good. Family is doing well. Thanks for asking. Hope you and yours are doing well as well. Whoa, hold on. Someone got 2 job interviews this week. I missed that. What's up, Vinegard? I'm sorry that I missed that. Congratulations. That's phenomenal. Good luck. Let us know how it goes for sure. We definitely want to hear about it. But again, take every situation like this, take it as a learning experience. You know, everything we ask you that makes you uncomfortable, that you don't know, write it down. Go watch a video or something afterwards about each of the things they said. Learn how to be conversational about those things. You'll be dope for sure. The link to Mastermind Academy is academy.mastermind.io, and !register if you want to grab the link to any of the, I think I spelled academy wrong. I spelled academy wrong, so don't click that. You know, I tell you these things right up front for a reason, but it's academy.mastermind.io if you want to get there. That's all good. Yes, my VS Code theme, it is Legendary Dark is my VS Code theme. And it is, it's just Legendary Dark. This is new to me. This theme is new to me. I switch up my themes probably once a month, right around once a month. I'll switch up my theme, but yeah, it's pretty dope. I pressed the link. This guy keeps DDoSing me. Yeah, that's definitely pretty unlucky. All right, so we are simply going to copy this file to another file. Let's call this slices.go. And we got a new file here, and it looks exactly the same, right? And we'll change this from our first array to our first slice. And the only thing that we need to do is we need to remove the number that is in, oh wow, that was not good. There we go. And we just remove that, and this is now a slice. This now tells the computer to tells the compiler that, hey, this is this is a kind of a dynamic array, and we're going to interface with this a little bit differently. And yeah, we can use this. Now, let's talk about how you speak about these things. When you have a slice of integers, that is what you call it. It is a slice of ints. It's a slice of integers. If you have a slice of strings, you have a slice of strings, and that's how people talk about it. So let's run it really quick. And when we run it, it looks exactly the same, doesn't it? Again, slices are still using arrays. The same thing is happening, but we are just interfacing with it different, and it gives us some magic. I can put any number of items in here, and it will take it and be fine. We don't have to specify it. So right up front, that's what you need to write up front, and now we'll break down the differences a little bit now. I'm doing a program for IT help desk to get my feet wet in IT. That's good. And pay for life while learning programming. That's dope. That's really good. Like I said, I started out at help desk. Help desk has a special place in my heart. I think the best part of help desk for me was it made me find, one, it helped me be able to speak to a customer, which is a really definitely a valuable thing. And it's something that people in tech often, it takes people in tech sometimes a while to pick up that skill, and it can take you can get very far off of just being comfortable talking to a customer. People will hire you, especially like contractors and stuff who have outside customers that they're serving. They will hire someone who simply has decent interfacing skills and mediocre technical skills over someone who has amazing technical skills, because you know, you're literally like people really do like people, and building that relationship, they want to, like, it's pretty important. You can, that is part of your tool belt in here. I'm not saying if you're someone who has bad soft skills, like, that doesn't mean you can get a job, you can't get a job or anything like that. No, but it is absolutely part of your skill set. And I think that is something we're going to start talking about on the channel a little bit more, is how you can leverage those soft skills, because a lot of people have amazing soft skills, and you can really get yourself pretty far in lieu of really hardcore, like hard skills. You know, it's a part of your package. So yeah. Do you compile all your code in CLI? I think Go is a compiled language. It is a compiled language. When I'm typing in Go run, so I do, yes. But when we're typing Go run, it is actually compiling our code. I know it looks like I'm just running the code like an interpreted language like Python, but it is actually compiling it, and it's compiling it to a temporary directory, and it is running that code, and it kind of sticks around over there. We could compile it to an application if we wanted. So we could, and so this is kind of what compilation looks like. So I just ran that. I can actually do a Go build, and we'll do O2 slices.go really quick. And it'll actually give me a new file. Check this out. It's green. It's also much larger, okay? This is an executable. It went through and it built that code. It wasn't very much code, happened very quickly, but check this out. Now I can simply run O2 slices.go, and it's its own little application. I could, if you had a computer of the same architecture as mine, I could pass it to you and you could run this code, no problem. So, you know, it makes it into a nice little thing that you can execute, an executable that you can actually run. So I'm gonna delete that though, but so every time I do Go run, it is actually doing a Go build, but it's building it to another directory, and then it is actually running that code. All right, so this is our first slice, and it is a slice. And so also let's you know, let's see what the type of it is. All right, let's see what it says the data type of this is. Oh, whoops. Why didn't it for slice? Oh, no, that's right. What happened? Why didn't it print any? Did I not save it? Hold on. Oh, we have a problem. That's fine. Redeclared main block. That's okay. Oh, because I built it. Thank you. Thank you very much. I didn't mean to build it, but you know, because we built it, we might as well run our executable. You're right. Thank you for catching that. And we can just run that executable again. And it says it's a slice event. Okay. It just shows it as a slice event. Now let's actually do that. That's gross. Let's put in a new line. I really despise not having new line characters in here. Just so it's a little cleaner. Oh, well, why didn't that happen? Because we need to rebuild it. This is dumb. I shouldn't have been building this, but whatever. New line character, cool. It says it's a slice of int. Let's actually see what happens really quick with the array. What happens when we do that with the array? Does it also show as a slice of integers? So I'm gonna rerun the 01. Whoops, I don't know why that 0 was there. But it does, but check it out though. It actually shows it as an array. Remember, that's the difference here. That's the difference in interfacing. It shows it with the amount of items inside of it, okay? All good. How do you unbuild Penguin Airline? You don't need to unbuild. It doesn't do anything with the file. Like the source code that you are compiling into an application, you don't need to unbuild it because you still have that source code right here on the computer. Good question though. All right, so, but if you want to remove it, if you want to delete it, you can just, you know, RM it, get it on out of here. All right, so that's great, super exciting. So we now have a slice here. We have a way to collect some data. How do we reference an item in here? And so let's see, reference item in slice. And the way that we reference an item in slice is using that bracket notation again and using the numbered index. So if we go, if we want to see something, I'll leave the print here because we can just use this print statement, but we just use bracket notation. So X will print out the entire slice. But if we put some brackets there and we say, hey, go ahead and give me 0, go ahead and give me the item that's in the 0 index, it's going to reference the very first item in the list. Remember, those things are 0 indexed. Okay, so if we go run that again, oh, 2 slices ago, .go. I really need to leave in that new line. It tells us, hey, that's the number 5, okay? And so if we want to see the last item in the list, we say, hey, go ahead and show me, what is this? 0, 1, 2, 3. So 0, 1, 2, 3, if we want to refer to that number. And we put a 3 in there. And that is how we reference an item in that list. How you doing, Mace FPS? Good to see you. What's up, Deshaun? Stefanovic? I tried it, Stefanovic. I did my best. Welcome. Let me know if I got that all the way wrong or not. Also, what's up, Sam Diva? Welcome, Yoxil. Welcome, Landlatch. Welcome to the channel. It is good to have you all here. It's good to see you. Okay, so that is something that we can do here. If we want to reference an item in the slice. What if we want to change an item in the slice? Well, if we want to change an item in the slice, we can use the index value to change it. So we've already declared and assigned value here. There's also another way to declare slices. We don't need to, I'm going to show it to you, but we don't need to do that tonight because it gets a little bit annoying and kind of the understanding of what's going on. We don't need to know about all of those things tonight, but we will talk about them a little bit later. But changing an item in a slice, let's say we want to change the number 1. If we want to change the number 1 to 47, okay, the way that we can change it is to reference it by its location. So X, so the slice X and the 0, 1, 2 spot, so the second index here, we just assign it a new value. So instead of 1, we can change it to 56, okay? And now, if we format.println the whole thing, format.println X, we can now see, after it prints out, after it prints out this, it's going to print out the whole array. The third item should now be 56 rather than 1. And let's see that. What's up, Ayushi? How are you doing today? Welcome to the channel. Good to have you. Thanks for the follow. And check that out. Now the third item is 56. It is actually changing that the data that is inside of memory here, okay? So changes it to 56. Great. Very, very exciting. So we can change an item just like that. We can also, let's see, we can add an item. Add item to slice. And if we want to add an item to a slice, this is where we are going to use our first, function here for this, for learning how to do this stuff. And the way that we would do it is using the append function. Append is, I love that pretty much everyone uses this. So this is the same thing that you're going to use also in Python when we get there in a second, but we are going to append a new item to this array. And so the word append, that's what it means. It means to tack on to the end. Prepend is putting something at the beginning. Append is adding something to the end. So this will add an item to the end of the list, okay? Or to the end of the slice. But that append function, it is built in to Go, and it takes 2 values. And we can go look at it in the standard library. It's a function that takes two parameters. We haven't learned about functions yet here. We will learn about it. I'm giving it, I'm introducing you to the words and to the phrases with the understanding that you don't know what it is yet. But it takes in 2 items and it uses those 2 items to do something. But we must save the value of that output. So if we want to add an item to X, we got to go ahead and append to X. Okay. So X equals append, and we have to pass it 2 things. We have to pass it the slice that we want to append to, and we have to tell it what we want to append to it. So if we want to add a new number, let's say we want to add the number 35, we have to say, okay, X is the slice that we want this to go into, and we want to append, 76 to it. Okay. So now let's talk about what's going to happen throughout this code right now. So the first thing that happens, let's close this. We set up our slice. Then we reference one item in the slice. That is actually the second item in the slice. 0, 1, 2. Don't forget it's 0 index. Then we're changing an item in the slice. So the second item, so that third item in the list, which is at the second index, we're changing to 56. Then after that, we are appending, we are adding a new thing to this slice, okay? And so we should now have 4 items. 1, 2, yeah, we should have 5 items now after this is done. So let's run this code. And check that out, okay? We still get that printout that we were supposed to get from the other line, but that append allows us to have that right there, okay? Makes it super easy to do. Thoughts on, and I appreciate that, Mace FPS. I do appreciate it. Thoughts on low code. By low code, if you mean low level coding, dev jobs have been lost. Yeah, I wouldn't. I would only do it if I was already well versed in software, because I just think the learning curve is high and the jobs are niche, kind of. They pay super well, but there's just not as much. There's just not as much of a market for it. But there's probably pretty significant job security though, because there aren't a lot of people in it. But yeah. Shouldn't that function return be like void, or is it different than other languages? So function return, so the way to return a function or value from a function is simply return, but this function right here, it has a return statement inside of it. We can go look at the actual append function right now. And it just returns the data after it does all the magic underneath the hood. We are capturing that in X. So right now, we're not writing our own functions. This main function doesn't need to return because it's the entry point to the application, and it has nowhere to really return it to. But yeah, we haven't really written any functions yet, but we do need to return items from functions when we do get there. But yeah, and let's move on to, but yeah, so I do recommend, again, Go By Example is really good for this. If you want to see the different options that you can do, it kind of shows you all the different ways you can reference things. Also it shows you how you can, we added it this way. So that's how you can change the value here. Actually, this is a good, this is something I don't know. I've never done this. I always append. I feel like you have to append. I feel like you must append because of the way, I feel like you must append, but let me see this really quick. I wonder if, let me take this. What happens if I do this? What if I do this? I don't think this is gonna work, but I'm gonna check it out real quick. Yes, it's Burning JC. So my problem though is that I rely a little too much on Go By Example or example websites. I almost purposefully do not remember syntax because I don't want to use up the space in my brain. But you know, it's kind of weird. Let me see if this works. Okay, it doesn't work. I didn't think it would work. But I just wanted to kind of see if I could like choose an item that was outside of the range that currently existed. And I cannot. Whoa, what do we do? Okay, cool. There we go. And yeah, Go By Example, like I said, is a good place if you want to see quickly how to do the thing. But that's why I'm giving you the example website, because I want you to know what you can do, and then you can always go find out the syntax to do it later if you know all the things that you can do. All right, so yeah, let's hop over to Python really quick. Let's hop over and do our first collection in Python with lists real quick. Let's hop into our Python folder and let's do 01 and we will do lists.py. And again, you're gonna see this feel a lot simpler than anything we've done before. And so let's set up our first list. So our first list. Whoa. Okay, so X again. And the list, you just need the brackets. That's all you need is the brackets to specify what you want. Again, lists work a little differently. There's no, it's not a fixed size, so it can be as many things as you want. It also doesn't need to be one data type. It could be a single data type, but it could be whatever you want. So we could do something like 2 or 3, and then, the word 2 for some reason, because that's weird. And then you can put in some other numbers. And I could even put in a Boolean value, like a true value, okay? But it is a collection of items, it's a collection of things. And if I go ahead and I try to print this out to the console, go ahead and print X. I don't even know why I just did that way. And we run it. True is not defined. Maybe it's capital T. So use capital T instead of lowercase t, and it prints out just fine. It prints out as a collection. Underneath the hood, Python is doing some pretty cool magic to kind of handle this and make this happen. Works well. I do like, again, these are one of the reasons, because you don't have these rules, and these are the things I want to start breaking down to you. Because you don't have these rules, a language like Python is really good for prototyping a new project or a new application. If you need to get up to speed really quickly, something like Python is usually pretty good for that. And it's good for getting started on things quickly, for tasks and things that aren't. Well, yeah, right now, that's the first paradigm, is if you need to do quick prototyping, if you need to get something up and running really quickly, because you don't have all the same rules, languages like Python are usually a good go-to for those type of things. Compiled languages, people find their benefit. The benefit really digs in for larger scale things. Those rules really do make things easier for larger scale projects. And when there's a lot of management things going on, when both security and performance are key, those rules are really, really important there. But yeah, but this works well for a lot of stuff. Iterating over a collection of different types. Let's see, hold on. Works in Python 2, yes. Iterating over a collection of different types. So you can still iterate over this completely fine. I'll show you guys how to iterate in both of these languages. You can iterate over this completely like anything else, okay? Yes, Go has a substantial performance boost, but for smaller things, that usually doesn't matter. Computers are so fast now that for certain tasks, it's not really a big deal. So it all depends on your use case, using the right tool for the job. Okay, so the same thing works here. If we want to reference, let's say we want to reference item in list. Same thing. If we want to do that, we just do a print, and you can use the same notation. So if we want to reference the second item in the list, we just use the number 1, because this is also 0 indexed. Okay. And if we should run that, it prints out the word 2, which is the second item in the list. And so that bracket notation works exactly the same way, okay? What else do we do? If we wanted to change an item in the list, same thing. If you want to change an item in the list, change value of item in list. Also, I figured out, you know what? Let me see something. I also think I figured out why I can't type, and it's why I'm standing up. I think it's the way. One, I think I'm afraid typing in front of you all a little bit, but I think it's also my arm, my muscle memory is way off because of where my arms are. So let's see if this helps. But now I feel all short on camera, and it's different, but it's all good. All good. Let's see. Change value of item in list, and the way we could do that is X of, let's say we wanted to change 827. Let's say we wanted to change that to yellow, the string yellow. So that would be the second item in the list, and equals yellow, like this. Okay, and then let's go ahead and take this right here, let's paste it. Let's also just paste the whole thing. So it doesn't bring me, surprisingly, it doesn't bring me anxiety per se, but my brain just like, it it cannot focus on typing for some reason, man. I really don't feel any anxiety over it, but my brain is like, yeah, well, we're just not going to do this efficiently or effectively at all while this is going on. And so now you can see it changed this item. It changed the number 827 to yellow. So very similar things here. Looks almost exactly the same when we get to that point. In the same way that we can do append, add item to list, we can remove items from the list. But I don't really want to, I want to show you where to find all that stuff. I just want to show you some of the basic stuff. And before I forget to show it to you, W3 schools. This is always where I'll send you to do these things. References for, see, I usually just learn Python. Here we go. And so they have a section here specifically for Python lists, and you can see all the things that you would want to do in these lists. Okay. Oh, I didn't show you guys length. We learned length for strings, but I can show you length for this as well, because length is for collections, but it's exactly the same thing that we learned before. But adding item to the list, is it the same way? Is it, it might be this, x.append. I think it's something like this, and then we simply append something to it. So let's say we wanted to append something to this. Maybe we wanted to append, I'll append my name. I think append is a method on top of this, and I think this is all that I'll need to do. There might be two ways to do it in Python, but let's see. Let's see if that works. Whoa. And look at that. It does in fact append to the very end. So x.append, it is a method over top of this because so I'm gonna tell you about this. You are not gonna learn about this until like week 6 or 7. Okay. The reason why I'm using something like this, the reason why it is a method is a dot append. These are functions. They're little pieces of code, little tools that are attached to something called a class. Python is an object-oriented programming language, whereas Go is not. It has some object-oriented functionality and tendencies, object-oriented like nature to it, but it is not an object-oriented programming language. Don't worry about that. Again, I'm throwing the words out there. Write it down. Maybe you might want to go look it up later if you want. But everything in Python is something called an object. These objects generally have a class to them, and X is because of the class that X is, because of the type of thing that X is, it allows us to perform certain actions against it, and append is one of those things. And so again, if you look through W3 schools, it can show you how to do all the things that you could do to it, okay? So yeah. Python utilizes different types, of course, but it's not strict, hence iterating over them without errors. Yep. Increase my typing speed. I'm really, it's really working though. I'm really getting good, but I need to start practicing in front of you all as well. Am I using any specific typing course? So I was using Rada type. Hold on, something like this. Yes, I was using Rata type. This is what I was using to learn, and it did help a ton. If I'm going slow, I'm very accurate, but then my brain just moves way too fast and I'm not accurate. So now I just do a lot of type racer and Z type. Z type is where I play a lot of Z type. All right. We might as well you gotta just hop into it a little bit. I'm gonna fail. Oh no. See, and then I freaked out because I missed one letter and now I can't type in front of you guys anymore. See, it's too difficult. But Z type is fun if you want to do it. Also, it's cheap on Steam. Typing of the Dead. If you've ever played House of the Dead, it's called the Typing of the Dead. It's a pretty ridiculous game. Definitely wouldn't allow it to be released today, to be honest. Definitely has some interesting overtones. But yeah, Typing of the Dead is pretty fun if you want to have a fun way to kind of practice. Those are the things that I'm doing, and it is working. Like I said, it's not the fastest process in the world, but it is working for me. All right, so there we go with lists and Python. You can do a bunch of other stuff to them, but you can see the examples look kind of the same. There are a bunch of other things you can do with this. We need to hop into the other two, to the other things. All right, let's go into the next different primitive data type. So these I'm going to show you 3 collection types. I also want to be very clear that there are more, especially with Python. We are not going over all the collection types in Python tonight. These are specifically the Go collection types, and the only reason is because I think this covers the styles of kind of the collections, but we'll touch on the other ones in Python a little bit, specifically sets and tuples. We'll talk about that in a second. Maps is the third one. This is good. Actually, this is good. So maps is the last one, and this is a maps are a collection of keys and values. Okay, so it's a collection, but that collection is of 2 things. It's a collection of 2 things. It's a mapped value. So I'm mapping a key to a value. Okay, and you've seen things like this before. In Python, they're called maps. In Go, in Python, these are called dictionaries. So what is a dictionary? Think about a dictionary in your head. What is it? It is a list of words. So that's the key. The word is the key. You know what page to go to. You know, if I'm looking for the word bottle, see a bottle on my table. You go to the B section and you find bottle. You find that key bottle, and it gives you a value. That value is the definition. That is what these maps are. And again, they're called dictionaries in Python, which makes a lot of sense. So let's talk about maps really quick. Now, nope, I'm not gonna talk about that. Let's just hop right into maps. Let's go back into Go. Let's create o3-maps.go. All right, and same thing. We'll set it up here. Package main, and we'll simply do func main, tab it through, and let's do a map example of a map. And there's 2 different ways to make a map. There's also 2 different ways to make a list. I didn't show you the second way. There's this make keyword. You'll see it. You will see it inside of Go by example, and it might confuse you. We're not going to use that right now. We're going to keep using the way that we've kind of been learning things so far, and we'll use the shorthand method for doing this. So I'll just do X again, like we do in all of these, and we'll set X equal to a map. And so a map is a type here. So what actually does help is that VS Code, when you're in VS Code, if you click, like once you install, so I installed the Go extension, the one that has this little thing here, I don't know what this is an image of, but when you see this bottom image and you click it, it will give you, it'll fill in the structure of something for you, of whatever that thing is. It'll do it for functions, it'll do it for a lot of stuff. And when you click it, it'll set it up for you. Now you got to fill in the actual data, but it fills it in for you, which is really nice. But this is a map. Whoa, redo. Okay, well, I messed that one up a lot, but you know, it's fine. But map is the type of thing we are making. And then we're gonna put some parentheses here. I mean, some square brackets here. And maps, it's a collection, so that you can kind of think about it like an array, but again, it's keys and values. So on the inside of these brackets, you are gonna put the data type of the key, whatever the key is gonna be. So the key could be something like name. And maybe you want to make a map of people's names and ages or something like that. And so the key is going to be of type string. All right, but the value, maybe it must be the same all through here as well, but maybe the value is also a string. Okay, so these can be different data types. It's fine, but the key or the value must adhere to that format. And then we kind of make it just like we made some slices. So the way that we make a map is say, hey, they both need to be a string. So name, I'm gonna set that to the separator. The thing that separates the key from the value is a colon. And so the key is name, the value is Aaron. All right, so that's one key value here. And maybe I also wanna do age. But remember, it needs to be a string. Both things need to be a string. So maybe my age is 30. Let's put the number in there, but it is a string. Okay, so we have 2 items in here. It's a collection of keys and values. So this key and value is essentially one item. It's one element in the collection. Okay, and what we can do is first print it out before we learn about all the things that we can do, and just see what it looks like when it's printed out. go. Oh no. Not got run, go run. All right, and so this is what it looks like. It says, hey, it's a map here, age 30, name Aaron. Also look how it came in a different order than I put it in. Not super important right now, but just notice, just something I want you to notice, that it is not in the same order that I typed it in, okay? Yeah, not a big deal. So that is a map, and we could just keys and values. All you need to think about is keys and values. It's a collection, just like a list or just like a slice, but the collections of keys and values. How do you refer to each of these things? Let's see a reference of individual things. What if you want to get the value or the key? It does get a little complicated in here, and so I highly recommend you to save that go by example, because it shows you how to reference each of those things. But we can reference a, if we want to print out a specific thing in here, I want to print out name. Okay, so if I print out X name, what do you think it's going to give me? It's simply going to give me the value of the key in the map that is name. So the key is name, so it's only going to give me the value of the key. Okay, absolute. The difference between a map and a dictionary is how they're referred to in each language. So a dictionary is this same data type, or it's the same data type in Python. So dictionary is for Python. That's what Python calls this thing. Right now we are writing Go right now. This is Go, and this is called a map in they're essentially the same thing. They are very similar in what they do. So we're gonna write this in Python in a second, but in Go, this is how you do it. No, 100%. Ask those questions. No, don't apologize for any questions. Don't apologize for anything. Ask whatever is needed to make things clear, as clear as possible. You won't always be 100% up to speed on everything, but if you need some clarification, that's a great question. Especially, it's also a great question because we're learning two languages at once. So you all are getting a little, there's going to be a little more confusion for you, I think, in the beginning of your path right now. I think that this is introducing, I understand that it's introducing a little bit more confusion than other people who are embarking on a singular language. I do think that it'll get you to understanding the concept of the thing faster and ultimately speed up your development process. So don't think that it's lost on me that kind of paying attention each night to two different languages can be problematic. I definitely get it. Is there a way of index by values instead of using keys? No, not by index. You can get the key, so these are iterable lists of things though. So like I could do like, there are 2 items in here. I didn't show you how to iterate over things. Iteration simply means that I can perform a task to these things over and over again. We talked about this a little bit, but I could do like something like I could do a little for loop and use the range function here. We're gonna learn about this. Don't worry. This is something that you're gonna learn. We're gonna spend a lot of time on, because we're only learning loops. I think we're only learning loops on Thursday. So we'll spend time on this. But let's say for I in range X, which is this map, and range is going to say, hey, iterate over this collection here, and I can go ahead and what can I do? Actually, format dot print line. Let me print I. Let me see. I think I is going to be an integer. I think I might have to do xi, but let me see. Okay, no. So it prints so you can iterate over the keys, and yeah, you can iterate over the keys, and it gives you the value right here, which is cool. But yes, they're right. Yes, the collection in maps is randomly sorted. So you can't simply use an index to access it. What's up, Haywood? Ah, man. Okay. Well, welcome, Haywood. I'm a child, and we'll just hello. It's good to see you. I'm glad you're here. I'm a little kid, a very little kid. Good to have you. But cool, yeah. So that allowed us, like if we had 100 things in here, this range function would go over all of them and print them all out. So I basically just printed out all the values. I can actually do both. I can actually do I can actually do like a key and a value, and I can print out like do I have to printf this and do like something like %v space %v new line and do like ki k. Let's try this. Let's see what this happens. But you can do keys and values through the range function. And there we go. We print out the keys and the values. So I can actually print out just the keys if I want by specifying 2 different variables. Again, not super important, but yeah, there we go. Thank you so much, Absolute, with the Twitch Prime sub, the war on advertisements. Congratulations to yourself for no longer having to see advertisements. Also, Pardell, welcome to the channel. Thank you so much for the raid. Come on in, everyone from Pardell's channel. I usually give people about 30 seconds to get in because they are not yet privy to the war on advertisements. And right now, I'm sure they're sitting through an unskippable 30-second advertisement. So we'll give them some time to come through. But Pardell, you're probably in just fine. Welcome to the channel. Thank you so much for coming through. Tell us what was going on your stream today. How did it go? Hopefully you all were learning a lot over there, having some fun, building some cool things, whatever you were doing. I'd love to know about it. Welcome to the channel. Thank you so much for the raid. Everyone from Pardell's channel, welcome. We are learning how to, we're on an 8-week journey to learn the basics of software engineering and computer science. Right now, we are learning about some primitive data types. We are learning about maps and dictionaries. For right now, we're about to move on to some more stuff, which we need to do right about now for time's sake. But yeah, that's what we're doing. That's what we're here for. We're pretty well, having fun building scientists with Rails. So that's dope. Rails, I really do like Rails. TDD, so test-driven development, pretty dope concept. Well, I'm assuming that's not some kind of framework I don't know about. And Tailwind CSS, I've been hearing some really amazing things about Tailwind CSS. Didn't Tailwind just release a I think they just released a pretty cool like component library that you can just kind of buy, but maybe not. Maybe I'm tripping. Nope, TDD with RSpec. Oh yeah, okay, cool. Yes, RSpec Ruby makes sense. I know. So I use RSpec I worked with Chef for a little while. Not the company Chef. I worked with the tool Chef. And we did a lot of RSpec tests. RSpec tests were kind of the only way you could do any type of infrastructure as code for a while, like infrastructure as code testing. Not really in a good way, but good enough. But yeah, Tailwind UI, that's what it is. I think I'm planning on using Tailwind UI or having my interns use Tailwind UI for a couple of things. But dope, welcome. It's good to have you. That's pretty dope. That sounds pretty cool. All right, so that is maps here. Let's see these really quick in Python. So Python, again, this is called a dictionary. And new file, O2 dash dictionary, dictionaries maybe, .py, that makes sense. All right, so dictionaries in Python look the same, okay? They look and they feel, they operate very similarly. So same thing, we can do an X equal to, and now we're getting into curly braces. So once you see those curly braces in Python, think dictionary, all right? And we can do the same thing here. And this can be, again, the keys and the values can be differing things in Python. It doesn't really matter because it's not statically typed. It can be whatever you want it to be. So name, same thing though. The separation is in fact a colon. Name is the key. The value is going to be Aaron. I forgot my name there for a second, which is kind of sad. That means I'm getting old. And age, which is another string. Let's set the value to the integer 30 really quick, okay? And let's go ahead and just print that to start, and let's mess around with these things. Now, because it's also a collection, just take it on back. I know we're not spending time learning how to add and subtract and everything to all these things, but because you know already in the collection now that you can append things, you can switch stuff up in that fashion, you can delete stuff, you can change different items, you can do all the same stuff here. So make sure, understand that there are a lot of actions that you can perform to these different things, and you might have to go look those things up, or you will have to go look those things up. So, oh, actually, I could have just created a new thing here, but let's do Python 3, and O2, which is dictionaries.py. And there we go. We get a printout of these things right here. But let's see if this is ordered or not. And so, well, let's see if they're ordered or not. We didn't talk about ordering and stuff, but let's see if we can see the first item in this list. Can we refer to an individual item this way? With this, with the index value? No, we can't. Same thing. We can't refer to it as an index value because it is the order. It is not an ordered list of things, so you can't do that. But can we do the same thing that we did with the reference of the label or the key here? Can we do that to get the value? And key error Aaron, yes, because it's looking for the key. There is no key error. There's no key Aaron. There's only a key of name and age. So let's fix that. Name. And it does in fact work almost exactly like Go. I'm hoping you're starting to see that even though these are two actually pretty different languages, you can start to see that these concepts transition over almost one-to-one in a lot of cases. Like the concepts really do transition well between them. It's just that compiled languages just generally have more of the rules. They have more concepts that you have to be aware of, but it's easier. It tends to be a little easier to move from a language like Python to one like this because a lot of the things that you know about already exist, but then there's a lot of magic and things that happen to make a lot of the other things much easier. So you can do it that way. And Python also has a for I in range. I haven't. Is this gonna work? I don't know. Let's see. Print I. You do things over and over again, and you forget. Let's see. It couldn't do find range X. Dictionary object cannot be interpreted as an integer. Oh, it needs to be a number. So the length of X, I think, is what we need to do. See, Python, but then we need to actually give it the, we had to do a little bit more, but all good. Doesn't really matter. We can actually make it, we can actually like eval over it. And there's a lot of cool things we can do. We'll get there. I don't want to dive into too much of that stuff tonight. We can get it to give the value. We can do some cool stuff with them both. I just wanted to show you that you can actually iterate over these things, although they are not ordered collections, so we can't refer to their spot by ordering. They are iterable, so we can go through them. We can iterate through them. And whenever you hear iteration, you should be thinking loops. We're getting the loops on Thursday, but just giving you a little precursor to it now. But dictionaries, all I really want you to know about dictionaries right now, or really I want you to know about maps. I want you to know about there's a data type or data structure that allows you to collect a bunch of keys and values. Okay, that is what I want you to learn right now. That's what I want you to focus on. There is a data type or a data structure that allows you to save a collection of keys and values. That's it. That's the lesson. Okay, that's what I want you to learn about that piece. And we can figure out how. Oh, for key and X, let's see. Oh, see, this is why people like. Yes, correct. For the key is that actual keyword, and I don't even have to do in range. Interesting. That makes sense because range in Go and range in Python are two different things. Range and Go allows for iteration over objects or collections, and range in Python has to do with a count of integers. And go ahead and print. Can I print like val or val is a values? Or let's try that out. Like if I don't want to print the key, or maybe I want to print for key in, or do I have to do like X key? Let's see. Now I'm on the lonely road here. There we go. Cool. We did it. Thanks for the second billing cycle for the quick, the quick syntax update. Again, you learn the tools. And then you'll learn them when you need them, and then you won't memorize them. It does get tough to memorize between different languages, but this year I'm really excited. I have some stuff to tell y'all about again my own path this year, and I'm going to be diving heavy into Go this year, but I'm going to be telling you why and what I'm going to be doing with it pretty soon. But yeah. Isn't KV in your dictionary items? So, isn't it for K and V? Maybe you're asking for the other one. Let's see. A for loop in Python defaults to iterating over dict keys for key in. Or I think X key. Isn't it KV? I don't know. I maybe. I haven't dealt a ton of, I maybe could be. That sounds, all of these things sound possibly right. But we could go look it up, no problem. Yeah, just like goes for everyone. You might say the majority front end. Oh yeah. So I need to go follow all this Tailwind stuff, because part of the things, some of the things that we're doing, Tailwind is we might have to buy a Tailwind subscription. Yeah, for programming style. Only course on you want books. So you know what? I do think I could learn from a book now. I haven't used a book for learning in a long time. I know that sounds crazy, but that's just generally not how I like to learn. But I can now learn via documentation, no problem. So I think books would work. Tailwind is a CSS framework, and so CSS stands for Cascading Style Sheets, and it is what makes the look of a website. So HTML makes the structure, and JavaScript makes it dynamic. CSS makes it look good, and it's a framework, so it's going to allow you to do some cool things much easier. All a framework is, if you're confused about what a framework is simply a package of tools. It gives you it like makes things that you want to do, and it makes them all the code for it, like it gives it to you in an easy way. So it does all the magic for you, and then says, hey, you just run this little thing and it'll do all these other things for you, kind of. But yeah, framework just makes it easy for you to kind of get some stuff done. It's a little toolbox. I'm seeing messages through the stream faster. Everyone always says that, messages through the stream faster than actual chat. So that's likely because maybe there's slow messaging on or something. I don't know, but because you're getting the direct chat feed from Twitch itself, through, like, that's what's feeding into my stream. I guess. I don't know. That's people have been talking about that for a long time. I have no idea why it's like that. Okay, so that was dictionary. So those are going to be your primitive data types for tonight. That's exciting, but we really need to hop through the other stuff, because the other stuff is pretty important. I actually would like to spend more time on that, but I think we're good enough there. So we're gonna hop straight into arithmetic and assignment operators. This part's, I like this part because it's high value and low cognitive load. Low cognitive load in that the concepts here I don't think are very difficult in comparison to the other things that we just learned. Ain't nothing like a little bit of high quality H2O, okay? You know, gotta watch Waterboy. I haven't watched Waterboy in a long time. I haven't watched an Adam Sandler movie in a very long time, so maybe I need to do that. Okay, math operators. We learned how to do a little bit with, let me roll up my sleeves a little bit, it's a little bit warm in here. We learned how to do some stuff with some strings. What do we do with numbers, okay? This is not everything. There are many, many things you can do with number types, but I just wanna introduce you to the basics. You can add, you can subtract, you can multiply, you can divide. You may not know about modulus, but I'll show you modulus and exponents. Okay, let's just do that really fast, because it is, it's important to see what happens here. But what we will also check is, yes, these are arithmetic operators. It's for you to do arithmetic, but some of these things also do apply to other data types, particularly in Python, but I will show you that because, yep, mama said alligators are ornery because they got all them teeth and no toothbrush, which is true. That is facts. If you look that up on the internet, that is the actual reason why alligators are ornery, okay? Lots of teeth, no toothbrush. You would be ornery too, just so you know. Just makes a lot of sense. I recently noticed Python doesn't seem to support ++. Why is that? I don't know why. I don't know why. That's a good question. I really like that you're asking that question, that you want to dive into that, because now I've never looked into that, because when I first learned it, I didn't think it was weird. I didn't think it was weird because Python was one of the first languages that I dove into. But now, yeah, I have no idea why it doesn't support that. But what you are going to learn is an assignment operator that allows you to do exactly that. Yeah, you got to do plus equals, and that is an assignment operator that we're about to learn. But yeah, I don't know why it does not support singular incrementation. I don't know, an incrementer. But yeah, let's do this. And so these are the signs in both languages. So it's no sweat here. We can run through this pretty darn quickly for the simple math stuff. So let's hop back in. I'm in Python. We can actually do it in Python first. You know, we're in the Python directory. Let's go ahead and let's do this first. So code-r 03. I'm gonna call it just math right now because I don't feel like typing out the word arithmetic. But yeah, so let's do a little bit of math. I'm not even gonna label it because I think you'll know what it is. And we'll just simply do this. We'll do 5 plus, let's do 5 plus, whoa, I messed that one up bad. 5 plus 5, and then we'll take this, paste it a few times, and we'll do 5 minus 5. Let's do 5 times 5. Let's do 25 divided by 4. And then, so let's do 25 divided by 4, and then let's do 25 divided by 3. Or not divided by, modulo or modulus 3. So this is Python. Okay, all these are in Python right now. You can obviously see it's in Python because we're using the function print. We also don't have all of the rest of the decorators of the application, like package main and the main function to make this stuff run. But let's go ahead and let's run this right here. Python 3. Okay, so we get some cool output. It is just like a calculator, okay, here. 5 plus 5, you add them together. The plus is the operator for addition. Okay, 5 plus 5, 5 minus 5 is 0, so 10, 0. 5 times 5, 25, so 5 times equals 25. Then when we divide by 4, I should have left, I don't actually know why I changed this to 3. Let's actually put that back at 4 so we can explain that. Okay, there we go. Same thing, that makes sense. But a little easier to understand. So division, so you know, this is the division symbol. It's slash, the same thing in Go, same thing here. And actually let's do an exponent as well really quick. 5 times 5. All right, so what just happened here? Oh, I didn't save it. 3,125. Okay, so this is the one you might not know about. So modulo or modulus is division. It's division. Okay, but it returns the remainder. All right, so it only returns the remainder. It does division, but instead of returning that value as it does on line 4, it returns what's left over. So 4, how many times does 4 go into 25? It goes in 5 times is 20, 6 times is 24. There's 1 left over for 25. Let's say we did it by 3. So 3 on the other hand goes into 25 7 times. Okay. Oh no, 8 times. It goes to 8 times. Also 24. There's also gonna have 1 left over. Let's go. Your boy can't do any math. Let me give you a different number. Let's do 21. Okay. How many times does 21 go into 25? 1 time. And it has 4 left over. And so this will give us 4. It returns the remainder. You'll use this more than you think you'll use it. But yes, it returns the remainder instead. It's pretty nice. But yeah, probably the same reason Python doesn't have a switch case yet. Wait, Python really doesn't have a switch or case statement? I thought it did. Really? Huh, I'm not sure I knew this though. Maybe I just assumed. Oh yeah, switch month. No, switch statements are there. Or is this something else? How to implement, so maybe it's not by default. Huh, interesting. For example, very, very interesting. I didn't know that. Yeah, it was Java. I didn't, maybe I did know this, and maybe I say this every single time. I probably say this every single time, but okay. Interesting. Wes, I mean, I'm sure I probably knew this. But I also just don't use case statements often as well, so. All right, cool. Let's keep moving along. So those are your math operators. Let's do it in Go really quick. It is much of the same story over in Go. Let's go O4 math.go. Much of the same here. Man, I needed to insert that snippet here. Package main, and let's go func main, and let's do our little bit of addition. So let's do a one line, format that print line, and let's actually get the same numbers really quick. Excuse me. Yeah, just so we have the same numbers, the same output. Let's do 5 plus 5, so same thing here. Okay. And we'll change it to, actually, let me practice my stuff here. Place minus down. Am I still in replace? No. Yeah, I am. What is this? Times. This is division. Whoa. And this is our modulo. And paste again. And replace that with exponent. All right. And now we can run this. And when we run it, it says, hey, invalid, indirect. Oh, actually, sorry, that was actually a very different thing than what I was trying to do. Oh, so actually, is that not exponent in Go? What is exponent in Go? Is exponent in Go this? Yeah, there we go. Sorry, exponent in Go is different. Sorry about that. Or maybe not. Actually, maybe not. Let's look up what exponent in Go is. But yeah, same thing here. So 5 plus 5, 25. 10, sorry. 5 minus 5 is 0. 5 times 5, 25. 5 divided by 5. We use all the same numbers here. Let's switch those up. Divided by 4. And I can just change this to something like 28 divided by 5. And there we go. Let's see. And you see our numbers are a little bit different now that we change those numbers up, but similar thing here. Let's see what exponents are in Go. Go exponents. Maybe you have to use something special for this. Oh, maybe, you have to do math. So it looks like for exponents, you may have to pull in, oh yeah, I think I knew this. Returns times, might be the power function. Huh, I really thought, Golang math. I really thought it was, well, I really feel like it was available to you right out of the box. Yeah, power, package math, and call POW. A little bit extra work there. Oh no, I did know this too. I remember I looked up why this was, but I don't remember the answer. It had to do with this, this package has some, so what I think what I learned when I looked this up is that that I don't know math the way I think I know math. And it was pretty interesting, some of the implications of the implementation of putting this, of not having this here, and like the extra value you got out of putting the stuff here. I didn't know you could do this much different stuff with exponents and even things like square roots. There's some cool intricacies in there. I remember looking that up and I was like, well, okay, that makes sense, but this is over my head and I won't need to do that. I won't need to do that at all. But yeah, yep. Cool. So we can leave that out for now. Not a big deal. Just want you to know that you can do math. Great. Very exciting. Super fun. Let's move on to the next piece because we need to keep moving. The next thing is these assignment operators. So this one is what we were talking about before. We were discussing in the chat a little bit that Python does not have something called plus plus, which well, not something called, it's not called plus plus. Plus plus is a thing. If you've ever heard of the programming language C++, this is something called an incrementer. And what this does is it increments something by 1. So there was a programming language C, and then C++ says, hey, this is C, but it's one up, it's one better, it's better than the last one. And C#, if you actually look at C#, it's actually C+++++. A lot of people don't know that, so it's, you know, a little play on some things, and you know, it's sharper, and you know, it's like a triple entendre when you go to C#. But yeah, it's pretty interesting. But we have some assignment operators here. So 1, we haven't learned about any comparison operators yet, which you're about to learn about some comparison operators. Assignment operators, these are things that assign they assign a value. They assign the value of the thing that's on the right into the thing that's on the left. That is the key thing you need to know about these assignment operators. And what we're going to do with this, we are actually only going to do this in one language because they are the same. They're also the same here, minus maybe the exponent one. But they're kind of the same. So let's do this in Go really quick. Let's do a co-r05 assignment.go. And what that's going to look like, how do I just move this back over here? Cool. No, that's not what I thought. It's going to, okay, sure. All right, so assignment operators. Let's say, oh, what's up, Dis105? It's good to see you. What's up, Jupiter Vision? Welcome to the channel. Come on in, everybody. Come on in. Welcome everyone from Dis105 channel. Dis105, it's good to see you. 2, how are you doing today? How was your stream? How's everything going? We are just learning we're kind of early on in learning our first bouts of logic for for how to code. This is kind of a general learning how to, we're working with assignment operators right now. We're about to learn about comparison operators and conditional flow, which we're about to learn about if statements in a second. But yeah, it's good to have you. Welcome, come on in. That's a good question. FDD or ODD? It's a good question, Disc. Okay, so let's go ahead and let's do this. What are we doing? Assignment operators. Okay, my bad. Let's do assignment operators. And so what assignment operators, again, what they do is they assign the value of what's on the right of this thing. They take the value of what's on the right of this operator and put it into the thing that's on the left, okay? Or they, sorry, not put it into the thing that's on the left. They perform this assignment operator to the thing that's on the left, okay? So they perform the action. So plus equals, it takes the thing that's on the left, it adds it to the thing on the right, okay? And then it saves that value into the thing on the left. I know it's confusing. I'm gonna show it to you. So, you know, there's something on the left of this, there's something on the right of this. Or each of these things, there's something on the left, something on the right. It performs the operation, that's what these operators are. It performs this operation, which is an addition or subtraction or multiplication. It does that action first. And then it saves the value into the thing that's on the left. Let's see what that looks like. So if you wanted to add something together, let's say we had a variable called, let's do y this time, and y was equal to 10. Say y was equal to 10. If we wanted to add something to y, the way that we would add a value to y, what in the world? Okay. The way that we would add a value to y is we would do this right here. We would say y is now equal to, and let's say we wanted to add 5 to it. The way that we will add to it was we would say y equals y plus 5, okay? Which is a little redundant, okay? And now we can print out, y, and we can see what the value of y is, okay? What is this? 05. And we run it. It started out as 10. We add 5 to it. It is now 15. Great. But that's a little, that's a little extra right there. That's a little, it's a lot extra, okay? And so what we can do is, instead of this, we can do a plus equals, okay? And so what it does is, again, it takes what's on the left, it performs the operation with the thing on the right. So it takes y and it adds 5 to it first. Great. It's great that it does that. Then it assigns the value to the thing that's on the left. Okay, so it adds them up, gets a value, and assigns it back into y. So this is the exact same thing that we just did here. And we still get 15 right here. This also works with a minus. So instead of adding, what happens here? Instead of adding, it's going to subtract 5 from y. Y was 10, so we're gonna get 5, and then it's gonna assign it back to y. So y is now going to be 5. Same thing for multiplication, same thing for division, all the stuff in there. This is what assignment operators do. They perform an operation and they assign the value. If it also helps, again, the equal sign itself, that is also an assignment operator, okay? It assigns what's on the left to the right. Whenever you see an equals, unless you're doing a comparison, which you're about to learn, it's mostly what you mean. You can make your own power function with x times equals x iteration. Oh, really? So you're saying that we could do, yeah, that makes perfect sense. That makes actually interesting. See, we got smart people here. That makes sense. Oh, it doesn't like that though. But there we go. 10 to the 10 power. That's not right. Is it? Yes. Oh yeah, it is. It is. Well, that's gonna do 10 times 10. It's gonna do 10 times 10 and not 10 to the 10 power. Not 10 times 10 times 10 times 10 times 10 times 10. It's not gonna do that. But yeah, I mean, almost. What if, what if just maybe it works? We'll just see. It doesn't work, but let's just see what happens. Okay, yeah, it doesn't like that. You gotta try it out. You gotta throw some stuff out there. Maybe you thought of something first, and maybe the language does it by accident. But cool. So you can do assignment operators like this. What's on the left gets assigned to the thing on the right. Phenomenal. That was quick work. If you have any questions about that, ask away, but it's pretty simple. It works for just about all of them. This works as an exponent in Python. These operators work in Python. So the thing that we were talking about plus plus is to add 1 to something. You would need to do plus equals 1 here. And this is what you have to do in Python. You have to do this in Python. In Go, actually, you can do something like this. You can't do it in this paradigm. This expression can't be just run like this. But whenever you see plus plus, it adds 1. Like this won't work here, I don't think. Oh, it does work? I thought you couldn't run this expression raw like this. Okay, well, maybe either that's changed or I didn't truly understand the reason why I couldn't run it in the paradigm in which I was trying to run it the first time. My understanding of what I read was you can't run a raw expression like this, which makes perfect sense. You should be able to, because if I did a loop here, this is the exact same thing that I would be doing. Really odd, but that adds 1. A plus plus simply adds 1. Does minus minus work? Okay, cool. Incrementer and decrementer, it is an expression. Phenomenal. But plus equals, which you have to do in Python, you got to do something like this. So yeah, there we go. All right. I use Google Slides for my professional development presentation too. Yeah, yep. I mean, it's the easiest thing to kind of go with. And I particularly use them over like PowerPoint because it's much easier to post GIFs inside of them, okay? Also, we talked about it being GIF or GIF. I mean, so, all right. It's for sure GIF, even though the person who created it is wrong about it, saying GIF. But one of my favorite YouTube channels, I told you, I expressed my love for the Linus Tech Tips channel, but he says GIF, and he said it like 2 videos ago, and I literally sat in my chair and considered unsubscribing because it made me, it like hurt. When he said it, I was just I was offended. I was so offended by it. Like, I really was offended, and I didn't like it, but we use it. We're using this because we can post GIFs in it. I was like, man, come on, Linus. I don't know if I can handle another one of these. Don't say it no more. Don't ever say it again, ever. Can't hear it. All right, let's get to the good stuff. My name is GIF. Yeah, I'm not saying GIF. I can't even do it for the joke. I can't even do, I can say Jeff, but I can't even say it for the joke. All right, so that was assignment operators. Now operators, just operators, period. Let's get into the logic of our code. Here are some comparison operators. This is so if the last operators were assignment operators, they were operations to assign things. These operators are to compare things. So it compares what's on the left to what's on the right. And the first one is a double equals. This is equality. This is how you check if something on the left is equal to the thing on the right, okay? So if it's equal, so these operators, they return Boolean values always, okay? The you're doing a comparison, and the answer that you get is true or false, okay? You always get a true or false value. Nothing else can happen. You say, hey, is the thing on the left equal to the thing on the right? Yes or no, true or false, okay? So that's what equality does. We'll see that. Inequality says, hey, is the thing on the left, it's the inverse of the top one. Is the thing on the left not equal to the thing on the right? If they are not equal, that is a true statement. Look at it as a whole statement and learn to read it that way. Hey, is 5 not equal to 4? Correct, it is not equal to 4. That is a true statement. It gets kind of confusing when you use the inverse. So I try to use equality as much as possible. Greater than, is the thing on the left greater than the thing on the right? Yes or no? Less than, is the thing on the left less than the thing on the right? Yes or no? Greater than or equal to. This is a kind of double operator here. It allows you to match two different cases. If it's greater than, it's true. So is the thing on the left greater than or equal to the thing on the right? If it's greater than, great, that equals true. If it's equal to, it's true. Anything else is false, so less than is false. And then the opposite here. These are super useful. You will use these all of the time. Now, I'm gonna show you equality operators in a second. D-Flare threw out a really interesting topic here on this. And this has to do with, I mean, this is particularly only a case with a JavaScript. Does Python have triple equals? I don't think Python has triple equals, does it? Yeah, I don't think it needs it. But there's sometimes you'll see triple equals, sometimes you'll see double equals. You usually see double equals for equality. So what is single equals? If you see one equals, that is an assignment operator. That is you assigning the value of what's on the left to the right. Double equals says, hey, are these two things equal? Are they equivalent? And let's see what that looks like. Let's change it to 06. And what are we gonna call this? Comparison dot go. And what we can do is we can set X, we'll set X equal to 30. We'll set Y equal to 40. Whoa. We'll also set W equal to test, and we'll set Z equal to, I also know that W isn't after Y and before Z, so don't yell at me. You know, it's just my brain thought about adding two more after I was already at Y, okay? And there was only one letter left, so I had to pick one. So, you know, I do know more letters, okay? Don't be mean to me, please. And Z is this other thing here. I'm only doing this to show you that you can compare. You can compare more than just integer values. A lot of times when I talk about comparison operators, people believe that you can only compare these integer values, number values. Strings can be compared as well. So let's see what that looks like. All of it looks like. And so we can say, hey, format.println, X is X equal to Y. Okay, what is this going to return to us? What is it going to spit out? What is it going to print out? You know, we're printing out something using format.println function. What's it going to print out? Remember, I said this always evaluates to Boolean value. So it's asking, is X equal to Y? Okay. And actually, I don't even think you can compare two different types. I don't think you can compare two different types, but you can compare different values. But let's see that. Oh, well, that makes sense. It basically failed because it says, hey, you set these things up. You declared W, you also declared Z. You made space in memory for these things. You actually give them values, but you do not use them. And Go will not allow you to do that because it's a compiled language. Okay. And is there a way to get rid of that in Golang? That was one of the big things I hated when Golang debugged. Get rid of what? Python does have is, which is Python's way of comparing literal, object literals, yeah. Is there a way of getting rid of, side question, don't mean to interrupt. Oh, that's a different one. But have you gone through naming nomenclature between the two? Oh, no. We touched on it yesterday, I think, surprisingly, but not here. And I'm assuming you mean the preferred method for naming things like variables and functions. The preferred method for naming variables and functions, I think in Python, I think it's snake case, I think. And I think that is Pascal case in Go. I think Pascal case being uppercase, all the new words. But the first one is lowercase. But yeah, I think we talked about it. But I don't remember if that's it for sure. I pretty much if I have to use something that is more than one word or a singular view of something, then I will usually Pascal case by default. But I do like snake case. I do like snake case, but a lot of other languages, that is absolutely not the preferred method. So I generally stay away from it, even though I really do like snake case. Yes, Python uses snake, so snake case. That makes sense. Can I scroll up? Oh yeah, up to here. Let me yeah, and so take a look at what it spit out. It spit out false. Remember, it spits out a Boolean value, true or false value. So Y, it said, hey, is X, which is value 30, is equal to Y. They are not equal, so it will spit out that number. Great. So let's do some of the other ones really quick. Format, let's take that. Man, I'm going through it. Oh no, redo. Yank it, paste it. There we go. So let's do not equal to. Let's do greater than. Let's do less than. Let's do greater than or equal to. And let's do replace less than equal to. All right, so we got a bunch of different stuff here. And let's run this. And so let's take a look at what our options are and let's see what we have here. So first, are 30 and 40 equal? No, they're not. That is a false statement. Is 30 not equal to 40? That is a true statement. They are not equal. True statement. Is 30 greater than 40? False. That is a false statement. 30 is not greater than 40. Is 30 less than 40? That should be a true statement. And in fact, that's a true statement. Is X greater than or equal to? These will also match these. So X is greater than 30. Oh, no. This should be a false statement. So X is not greater than or equal to 40 and X is less than or equal to 40. So what's really the highlight that I want you to see right here before we move into the next stuff, because we need to move to the last little bit here. The thing that I want you to really focus on is that the big standout is that for these greater than, the greater than and the less than, if the numbers are equal, let's say we made these numbers equal, these obviously, not obviously, but these are going to be false. If the numbers are the same, it's false. And because again, 40 is not greater than 40 and 40 is not less than 40. So this is both of these are false statements. That's why these also exist, to check either one. But just wanted to show you that because I find that that's also confusing to a lot of people. But yeah, so you can check those two things. Now for strings, let's say we were gonna compare, let's here's what we'll do. Let's use some magic here. Let's do it with strings really quick. Let's do it with strings and X and Y. Let's see if we can do some, how do you do this in, there's easier ways to do this. I'm gonna take 20 seconds of your time to work on my find and replace in Vim. What is it? Percent S slash X slash W. Oh, that's dumb. I shouldn't do that. I was gonna do that, but that was dumb. I was about to do something really dumb when I didn't need to. And I can just go X and Y. That was stupid. But you can do it with strings as well. And strings will compare the actual value here. So it's saying, hey, is X equal to Y? So it's looking at test and it's seeing if that string of characters is checking if that list of characters is equal to this list of characters right here. And obviously it is not. Those are two different things. So you can check whether or not a string you're expecting comes out. So you can check for equality. You can, like, the less than or equal to. I think what's the less than or equal to do? Does it do letters? I think it does letters, maybe. No, it does not, because the third one is true. I don't remember what it does. I actually don't know what is it checking here. X, Y. It's not length. It's X less than Y. It sees test as more. So that seems to be the greater item there. I'm not sure. Does anyone know what when you're doing greater than or less than, is it checking? I know it's not doing any like rude arithmetic or anything like that. I don't know. That's a good question. Go string comparison. Go string greater than. Let's see. Here, the equals and not equals are used to check if given strings are equal or not equal. The other operators are used, to find the lexical order. The result of the operators are Boolean type, meaning if the condition is satisfied, it will return true. Otherwise, it will return false. And so they're not even using this. So if the results of the operators are of Boolean type, if X equals Y equals false or true, I don't understand. I'm trying to, in my mind, from what I just read, they would all be true, but I don't understand what the comparison is here. Read that one more time. You can check if the given strings are equal or not. And greater than or equal to, less than or equal to, greater than or greater than or less than operators are used to find lexical order. If 10 is less than 20 equals, nope. Okay. Phenomenal. But the reason why they don't show you this is because I don't even understand. I don't know when you would use this at all, but I just want to show you that you can do it. Like, you can also do it with other data, like you can do it with other data types as well. You can do it. I don't know what the reasoning is. It's comparing their ASCII values. So yes, but it's not. What ASCII, well, so each of those ASCII values is an ASCII value of the character, but I mean, it's not adding the ASCII values, is it? Like, it seems like it wouldn't, it's not a summation of the ASCII values, is it? It's like, what is it? We can convert that to ASCII values, but it's going to be for the word test, it's gonna be 4 separate ASCII values, right? Like, is it just looking at that as one giant integer? You can sort a group of string. Oh yes, you can sort it. So yes, we can use a sort function to do that and get an alphabetical order. That would, sure. Is it checking the one that's in the most alphabetical of orders? A similar sorting 1, 2, 3. Yep, you definitely sort. It'll probably come to me in a few minutes. I'm gonna keep moving, but keep trying to explain it to me because I need help. If left dot first compared to right dot first, so it's okay. first I compare to, write that first, and then backwards through it. Okay, okay. Okay, got it. Got it. Yes, got it. Got it. I got it. Thank you. That helps. That helps. But like, why would I? Does anyone know of a? That makes sense. I do. That does make sense. Now I'm trying to figure out if there's a case. When might I use this? I've never had to use it. I've never had to use this or even thought about having to use this. So if you know of a way to use this, I would like to know. I would like to know what scenario that might be useful in. Okay, if you're trying to merge sort, okay. But that's if you're trying to merge sort a list based on the lexical values, which seems like something you wouldn't do. Yes, that seems like you could use it for a sort, but like, yeah, okay, that makes sense. That does make sense. That makes sense. Yes, that does make sense. Okay. 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 Let's go to that. That's interesting. I'm immediately, like I said, usually when stuff like this happens, I'm immediately going to, like, after this, I'm going to go try to implement some stuff really quick to mess around with that. Let's just sort unequal strings alphabetically. Yeah. See, okay. That, yeah. You can also just sort this. Yeah, that makes sense. It does make sense. Okay. But now I'm gonna go back and see if I can change my implementations of some of my sorts using that. Maybe. I'm still trying to confirm in my brain. It seems like a very specific scenario, but cool. Okay. Thank you. I appreciate that. All right. The last thing we're gonna do, and there's a bunch of slides left, but no. Two things. Really quick, you didn't know about this. And an or is how you can compare is how you can combine multiple operators together, the output of multiple operators together to determine one logical statement. We're going to do that with the ifs, though. We're going to learn all this at one time real quick, and I'll show you what that is. But conditional operators, okay? More logic. Conditional operations. Control flow. You're controlling the flow of code in your application. You're controlling what happens and when it happens, okay? This is very, very important. If these are ifs, this is if statement. So the way that this works is conditional execution. It's based on conditions. If something is true, do something else, or do something. If something's true, do something. So if something is true, you should already be thinking about Boolean values. Do some code, run some code. If not, don't run the code. If something's not true, don't run that code. But if something else is true, if something else is true, then do something else. Okay? And then else, if nothing else is true, go ahead and do this thing here. So this part is a little confusing at first, but it's really nice because the keywords in most languages are just the word if, and this is going to allow us to control the flow of our code. We can say, hey, I only want you to run this bit of code if this scenario, if this statement is true. And this is where you can now combine in those logic operators and those comparison operators. You can say, hey, if X is greater than 10, I want you to run this code. But if not, I don't want you to run the code. Or you can say something like this. If X is greater than 10, so it's greater than 10, and X is less than 50. So if you only want to run it for numbers, only want to run this code for numbers that are in between, from 11 to 50 or 11 to 49, then you say, you can say both of these scenarios must be true for this code to run. And so the and or operators help with that. And yes, the and is the double ampersands, and the or is the two bars, is the two pipes. Okay. And don't worry about not right now. But yeah. And we're not gonna do switch yet. We are gonna learn switch. We're not gonna learn switch yet. We're gonna learn switch on Thursday with the loops to kind of show you some of the stuff. And yes, opposite day. It's exactly what it is. I'm watching while working out. That's pretty dope. I wish, see, it would be pretty nice if I could just get a Peloton. And right now, I could be teaching and Pelotoning, and things will be great. That's why I'm on my little balance board right now. That's why you see me moving around a lot and getting a lot shorter when I go left and right. That's dope. Want to catch every strip from here on out? Dope. I appreciate that. Looking forward to seeing you. If you can't make it, no big deal, but that's pretty cool. I need to start watching some Twitch while I'm working out. All right, so let's do the conditionals really quick, and then we'll be done. We'll wrap it up. So conditionals are pretty dope. This is where your code gets fun. We will implement real things with conditionals. We're going to implement some real. We're going to like work through some problems on Thursday after we learn loops. We'll probably spend 45 minutes learning loops only, and then we'll go through a couple of problems together. So let's see. I would love a Peloton. I got into cycling early on in the pandemic. Back in March, I got into cycling. I have a pretty nice bike. I put a lot of miles on it. I went from riding 2 or 3 miles a day to riding 50-mile rides. And I was planning on doing a 100-mile ride when I left my job, and unfortunately, I had a bunch of I was trying to get it all together, and I had a bunch of mechanical issues, and the bike shops were all super crowded because everyone bought a bike, and so I couldn't do it yet. But I do plan on in 2021. I'm doing a 100-mile ride for sure, and so I would love to get a Peloton. But the wait is like 5 months, 5 or 6 months, and I'm not buying a secondhand Peloton because it's too expensive. Like I need one fresh from the factory if I ever spend that much money. Maybe I'll try to. I don't know. Maybe I'll try something else, or I'll just, instead of spending all that money, maybe I'll spend a lot of money on some cold weather gear and just go out and ride my bike, because I do have a nice bike. That's in my mind, I was seriously considering getting a Peloton. So now maybe I should just put it literally put in 3% of what I would have spent on a Peloton into some cold weather gear and just go for a ride. But yeah, no, I'm pretty confident in my ability to ride a Century. I mean, people have told me. So I've done a 75-mile ride, and it was hard, but it wasn't that hard. And I know 25 miles is a lot more on top. 25 miles is no slouch of a ride, but the course that I would take, the Century that I would take, it's not a race. I'm not rushing. It'll take me a while, but I'll finish it. I think I can get it done. I'm gonna aim for 8 hours. I'm gonna try 8 hours, 8 to 9 hours on a mostly flat terrain. So there's a little loop we have over here. There's a loop around the airport, around the Baltimore Washington airport. It's a 10-mile loop. You can ride around that. You can ride another mile down the road, and then there is so it's a mile in between, and then a mile and a half in between, and then there is a 14-mile ride out to Annapolis. So from Baltimore to Annapolis and back, and then back and around the loop. So I plan on doing that. I think I plan on going twice around the airport to Annapolis, back twice around the airport, and then that's one go. That's 50 miles. Wait, twice around the airport. Maybe that sounds right. That might sound like too many miles. I don't know. I made the route. I'll figure it out though. I got my Peloton pre-pandemic. Yeah. I wish I would have too. I really wish I would have too. Cause I really I've been into bikes for a while. I did mountain bike for a pretty long time, and it's something that I really do enjoy, but I'm only recently into road cycling, and not really road cycling. I'm not out here with the cars, but there's a lot of long paved paths, but I like being able to just get on my bike from the front door of my house and then go far. Like mountain biking, you gotta pack everything up, get all your stuff together, go out and drive somewhere. It's kind of nice. But yeah, dope. That's dope. Yeah, there's some pretty good trails and stuff around here. All right, last piece. Sorry for the tangent. It's something that something I was a little bit passionate about. I want to talk about it a little bit, but I would like a Peloton. I really would. Okay, so let's make our last file right here, code-r, and we are going to go 07 dash conditionals. .go. And so again, we're only gonna do this in Go, 1, because of time, 2, because Python, immediately you'll be able to do this in Python. It is, it's almost exactly the same thing. The keywords are just different, but let's do this. And maybe we'll just do it in there as well. It's gonna help out. Baggage main, func main. Let's see, / example conditionals. All right, so we can say, let's set a value X. Let's set it to whatever number we want to set it as, and we'll say 87. random number. That's the most random thing I can think of. And then we're gonna do if, maybe we can see where our number is. We can say if X is less than 100. I'm now writing the wrong language of code. You say if X is less than 100, go ahead and do this thing. So the code that exists underneath here will only run if this statement, this is the scenario that we're setting up. If this statement evaluates to true, this thing has to be true for this code to run, okay? So as long as that's a true statement, this code will run. So if X is less than 100, go ahead and print. We can say number is less than 100. And then we can, so let's just do that. Let's just do this really quick and see what happens. And again, think about what we're doing here. The goal of what we're doing here is controlling the flow of our code. So we do go, run, and what's that, 07. And we run this and it says, hey, the number is in fact less than 100 because it took 87, which is X, and says, hey, is 87 less than 100? This is a true statement. Because it got true, it ran this code here. But what if we changed it to 187? What happens now? We change it to 187, we get nothing. And we might say, oh, did the code run at all? Yes, the code did run, but it evaluated this. This actually happened. It said, hey, this is a false statement. 187 is more than 100. This is false, so it does not run this code. It skips over this code, and the program basically ends because we didn't tell it to do anything else. What's up, Skyward Dev? Thank you so much for the follow. It is good to have you here. I live in the country, so I ride my foldable Schwinn on the streets of the rural area. Yeah, that's dope. There are some like, so I live right off of Falls Road in Baltimore. Falls Road is a huge like it's like a good scenic route, and there's a lot of cyclists on that road. It's too scary for me to be cycling on, but it does seem like a really cool road to ride on. But I ride on, I go to the BWI path a lot, the Baltimore Annapolis Trail. I go over to there's one that goes up to Pennsylvania. I forgot what it's called. It's some kind of railroad trail, goes all the way up to Pennsylvania. That one's really nice, pretty beautiful. There's a bunch of stuff around here. But yeah, roads not gonna work for me. Yep, we are about to make NCR Trail. Thank you, Mr. Moonslam. I always forget the name of this stuff. I like the NCR Trail. I've only ridden the NCR Trail twice, 2 or 3 times, but I had a really good time doing it. I haven't gone up to the PA line yet though. Oh no, yes I did. I went to the PA line once. The PA line is like 60 miles, I think, a round trip. It's like 30 miles up, 30 miles back. But yeah, NCR is really nice. I really like NCR. A little harder than, it's a little less flat. It's surprising. There's a surprisingly gradual climb there. I like the entire Maryland Park of NCR 3. Wow. That is, that's impressive. Definitely impressive. Dang, that's crazy. I've ridden most of the trails in Patapsco on mountain bike, but I don't have a mountain bike right now, unfortunately. But that's something that, you know, hopefully I'm gonna see how things work out when the baby comes, you know. Hopefully business is okay, and if I can afford a bike, you know, when it gets nice again, I'm definitely gonna get a mountain bike and start switching up a little bit, going mountain biking again, because it is something that I enjoy. Okay, so remember, let's go back to our stuff here. Conditional execution. So if something is true, go ahead and do it. If not, don't run it. But we want to be else add in some more things here. And so else if is something that we can add. So we can check for a different scenario to be true, okay? So using the else if keyword or elif, or there's a couple different ways to type it. Hopefully this is going to tell me what to type. Because again, I told you, I never remember syntax on purpose. And there we, I think it's just else if. So an else if, it needs another statement to be true. So we said, hey, if X is less than 100, go ahead and do this thing. Else if requires another scenario to check against. So we can say, or else if X is greater than 100. And here's where we're gonna use some of those other operators here, those logical ones. We can say, and X is less than 200. Okay, now let's talk about this real quick. Let's talk about what this means. And so it's gonna say, hey, is X less than 100? It's going to check that first. That might evaluate to true or false. And then it's going to check if X is greater than 200. Less than 100. Oh, or actually, sorry, switch those around. Let me switch those around. Greater than 100, but less than 200 is what I want. It's going to check those. For the AND operator, it says the thing on the left must be true and the thing on the right must be true for this whole statement to evaluate to true. When these are in here, this is one entire statement. And for the whole thing to become true, both the left and the right have to evaluate to true for this thing to be true. The OR operator says only one of them has to be true. And remember, in these if statements and these if else statements, as long as this statement evaluates to true, the code will run. So it's gonna make sure. So if X is greater than 100, and if X is less than 200, this code will run. And so we can write a little thing here saying format.println, and we can say number is between 100 and 200. Okay. So it's gonna, and what this does is this is actually one continuous statement block. This is all part of the same code. So these blocks, these if statement blocks, what it does is it goes through, oh, actually, does this need to be in maybe this? There, no, that's not it either. Is it, previous declarations? The problem is I have a bunch of other stuff in here. Main block, else, oh, is it not? Oh, whoops. That's why. Thank you. And I spelled else wrong. Thank you. So I might not even need it in, there we go. That looks better. And I probably don't even need it in these. Like I had it, I just can't spell. That was the crux of my problem. There we go. Perfect. Thank you for that. You know, I need help sometimes. All right, so let's run this. This if statement block, it will evaluate starting at the top, okay? So it's gonna run this first. These if statement blocks, once they find a match, it's done with, okay? It will not check all of them. It will stop at it'll run the code from the very first one that it gets to, okay? So that's a very important concept to understand. It will stop as soon as it does. So the number is 187. It goes through this. It says, hey, is X less than 100? No, it is not. It is 187, so it does not run this code. Then it drops down here and it says, hey, is it greater than 100? Which it is. And is it less than 200? Yes, it is. So that's a true statement, and it prints this. If I make it greater than 200, so that one of these is false, because look, because the first one is X greater than 100. If it's 201, this is a true statement. That makes this true. But this one's false. So this whole statement is false if one of them is false. Gross. I didn't like that. What do we do? 201. All right. When we run it, nothing happens. We get no output. We get no output because it doesn't match either one of those things, but the code does run. It compiles successfully. It's all good to go. It is valid code. Now, you might say, oh, that sucks. Like, now we got to handle every single option and check for things. You don't have to do that. There's one last operator, which is else. All right, so there's if, there's else if, and then there's else. Else does not need you to create a scenario to evaluate to true or false. Why? Because it's basically saying, hey, if the thing above me was not true, go ahead. If all the things above me weren't true, go ahead and run this. It's almost like a default case. It is not, I don't want to call it the default case, but it kind of is the default case. And then so we can do a format.println. Number must be greater than 200 or just greater than 200. Okay, so anything that doesn't match, basically we've now created 3 cases that should match every single number, period. And now we'll actually get output. So no longer will we get no output. We'll always get output. No matter what the number is, we will always get output now, which is great for all cases. Now, this is how logic operations work. This is how controlling the flow of your program works. If statements, if else if, else. An if statement starts an if statement block. All these are in the same block, okay? You can only have one if per block, okay? You can only have one if per block. You can have any number of else ifs, okay? You can have unlimited number of else ifs and only one else. So one thing to start it off, which is the if, unlimited number of else ifs and in whatever scenarios you want, and you can have unlimited number of else's. It does not matter if your else ifs, if like the scenario you create can be matched by the same numbers. It will match the first one it can match, and once it hits that, it'll run the code and it will not run the rest of these. Okay, so that's very, very important. Number is greater than 200, or maybe it is 100 or 200. Oh yeah, so yeah, I can do let's do less than or equal to. Yeah, that's a good one, because if I do 100, it'll be weird. And let's do less than or equal to 200. There we go. We can just do that. That's fine. Or actually, no. That needs to also go here. And there we go. If it's 100 or 200, this will work. So now if we do, you know, that's now going to be inclusive of 100. Cool. But yeah, so like I said, one if, one else. All right, you can't have two else's. Why could you have, doesn't make any sense. That's kind of the default case. It catches everything else. So else, one if, unlimited else ifs in between, okay? And that's what you need to know for this evening. That's all you need to know. So quick recap of what we learned. We learned about some different data structures, some primitive data types. They're really data types, but they're structures of data. We learned about arrays, which are fixed size collections of items, of elements of the same type. Okay, that is what an array is. Same type, fixed size, okay? Pretty dope, but it's a collection of elements. Elements that are not only iterable, so you can kind of go through each of them, you can perform an action on each one of them, but also they're zero indexed, okay? They can be identified by their index, starting with 0. All right, so the number spot starts at 0, we can identify them by that. We learned about slices and lists, which allow us a little more dynamic functionality of the usage of arrays, because arrays, it's difficult to resize an array. Arrays by default generally are not dynamic, and we learned that slices allow us to be a little more dynamic with them and not have to have a fixed size, but still has to be the same type in Go. And Python, not so much. You can be whatever types of things that you want to put in there. We also learned about maps, which is also a collection, but it's a collection of keys and values. It is iterable, but it is not ordered, so you cannot refer to things via their index, but it is a key value store for things. So we learned about those 3 things. We also learned, well, 4 things really if you include list. We also started to learn about what you can do with math. We learned about addition and subtraction and division and modulo or modulus, which is division, but it returns the remainder. So we saw that a little bit. We learned about assignment operators. So being able to take 2 things, something on the left, something on the right, perform an arithmetic operation to it, like addition, and then save that value back to the thing on the left. So we saw that plus equals, minus equals. It's pretty dope. We also learned a little bit about logical operators as well with the and or. We learned about comparison operators so that you can compare values. We learned that those always return Boolean values. So if you compare 2 things, you're going to get a true or a false. Equals to, less than equals, less than equals, greater than, less than equal to, greater than equal to. We saw all those comparison operators. We just saw that you can combine those with some of those logical operators like and or. And then we also dove into these conditionals a little bit and saw that you can use these if statements, these if statement blocks, ifs and else ifs and else's, to determine what code is going to run when it's going to run. And so you can set up a scenario that you want to check to be true or not, and you can run code based on if that scenario is true. And so, yeah, those are things that we covered tonight. We're just getting into the logic of code. And it's hard to know, like, we're touching it, but it's hard to know what you really are going to do with the logic of code until you actually start to be able to do those things. And so, again, the first thing that we're going to dive into on Thursday is loops. So you're gonna learn how to run code over and over again and understand that process. Will take about 30 to 45 minutes, like running through and practicing loops. And then we are going to implement, so we'll do our first fizz buzz for everyone who's doing fizz buzz. We'll do that very fast at the beginning, probably at the end of the first hour next time. And then we're actually gonna dive into, hopefully we can get through 2 new problems that are gonna use all of these different things that we've learned from the beginning of this course to like actually do a tangible task, like to do something tangible with code and to make something happen rather than just printing stuff out. Let's solve a problem, and we're gonna start to learn that starting on Thursday. So hopefully you're looking forward to that. Does anyone have any questions from tonight? I know we went over again, we always go over. This is exactly how long I put on the calendar though. I did put 2 hours and 30 minutes on there, but I'm really trying to get you out of here in 2 hours. So I've seen people using multiple if statements in different blocks. Great question versus the typical if, else, if flow. Is there an advantage to one over the other in Go? So that paradigm of programming is not language specific. That paradigm has more so to do, and it also has less to do with the performance benefits or the advantage of it. It's got to do with what happens to your code. A lot of times that paradigm is used. We don't know about functions yet. A lot of people tend to use that when they're writing a function and they put the return statement under the if. The reason why they do this is, let's say I'm trying to determine a couple different things. Let's take what we have up here. I'm gonna copy this really quick. That's a really good question though. It depends on what you're trying to do with the code at the time. But let's say I have this, and instead of doing an else if, I drop this down to a new block. It will evaluate every if statement in the whole piece of code. It'll evaluate all of it. So even if it drops, if this is a big long if else and it goes to the next if, it drops out of this and it's gonna go to the next if because that's a new statement. So they might do something like this: if, and then if. Okay. Here's the problem. Here's the problem with this. If let's comment this out up here. Ooh. No. Let's redo. Whack. I don't like the undo on this. Okay. Let's say this could match 2 different things. Let's check this out. Let's do, what if I did greater than or equal to right here? What if I did greater than or equal to right here? And I did greater than or equal to in this section as well. Check this out. If I do this right now and the number is 100, and I say, hey, is it less than or equal to 100? Yes, it is. And also I'm checking it against this. Watch what happens when I print this out. If, what doesn't it like? It doesn't like something. Oh, I can't do this last one, but just ignore. I'm gonna say if false. I don't want to print this. What in the world? Can I do this? Let's just do X greater than 200. Here. Okay, let's run this code really quick. And what we get is that it actually does both of them. Number is less than 100 and number is between 100 and 200. So the one thing to notice about something like this is if you need the if statement to evaluate, if you have to have multiple processes on it and you want it to be able to match something else, if statements do that rather than if else's. If we did an if else, again, like I said, once it matched this one, even if it matches this one, it'll drop out of it, and so this won't run. A lot of people use it in functions because a return function exits a whole function. It ends the running of a function itself. And so some people don't feel the need to do an else because they can do an if, and if the value is right, return, cool. Then we can go to the next one and it'll return on the first one that it finds. And it's a paradigm that works. There's also a number of other, like, when you are in the problem, the thing that you're trying to check, if you don't, there are some intricacies of what you're checking that matters. It's not a language specific paradigm. It has to do with the what you're trying to solve with it. There will be times when you do a bunch of just ifs. It happens, and and in the right paradigm, it makes sense. I don't love it, but it does make sense. That might be a situation where a case statement might work better. To be honest, there are case statements, but yeah, yep. Typically see it in functions for sure. What are those components called that we were using previous lesson? The %v, %t. That's a good question. I don't know what they're called. But what they are is they are an indicator. They're an indicator. They're indicator to the format.print function on the data type, or the type of information to return in the function, or to incorporate in the function. I don't know what they're called. I don't know what the name for them is. And maybe let's see, Godoc. Let's see. Not strings. Let's look at fumped. And I think it gave it to us right up top. The verbs. Maybe it's verbs. Maybe they're called verbs. So yeah, let's go with that. I've never heard them called that before, but yeah. Some people don't like deeply nested if else's or nested scopes in general. Yeah, scoping. Scoping generally, yeah, is why you might want to do that as well. I hate nested ifs are not my jam at all. I don't like that. Oh, they're called flags? Sure, let's call them flags. I like I said, I don't really know what they're called. The format verbs are derived from C's, but simpler. Great, flag sounds good to me too. Yeah, but that's what these things are called. And they can be found right at the top of the format package of the fumped package. Okay, people in Go call it fumped. It's so weird to me, but I get it. Like all the true Go, the gophers, they call it fumped. And you can see those here if you ever need to refer to it. Like I said, V will do its best to try to figure it out, but that doesn't always work. Definitely doesn't always work. It does some inferencing for the most part, and that's not always what you want. So it's good to go in here and look at these things. So that's it for tonight. I think that's it. I gotta get out here and get some dinner. I have not eaten any dinner tonight, and your boy's been on a work binge. Not gonna lie, but again, I always got to tell people. People keep asking me how's business going. I'm like, business is going surprisingly well for a business this young. Business is going well. But they're like, are you tired? I'm like, yeah, I'm tired. I'm always tired, but I'm not stressed. Like I said, I'm gonna sit down and I'm gonna do some work after this. We'll get some food, but I'm gonna watch something. I'm gonna watch something funny or good, or like I'll have my feet kicked up. I'll get myself some food, I might get myself it might be too late to get a coffee, but I'll be really comfortable. I'm and then sometimes I look up, I'm like, this ain't bad at all. But it is a lot of cognitive load though, but it's all good. But peace out, everyone. Thanks for sticking around for a little while again. So if you wanna build on what you're learning this week in particular, there's some really good overlap between pipelines and this. This is the coding week for pipelines. So pipelines are doing something like they're doing coding in 1 week, kinda. They learned everything about coding on Monday or yesterday, and tomorrow we are building a Python ETL process. ETL stands for extract, transform, load. It's going to be a simple process because we just learned how to code there, but it's to show how you would use a programming language to automate a task, especially in the infrastructure space, the infrastructure software delivery space. And so it might be a good primer to start to the building of certain things. It might be a little bit fast paced, but if you want to come out and check that out tomorrow, that should be pretty fun. We'll be back on Thursday here, and we will be building. We'll be writing solving our first problems on Thursday as well. So we're getting there. We're making our way through the process. So, what are we doing on Friday? On Friday on Horizons, if you're interested, we're going to be doing S3, everything about S3, simple storage service. We'll be also showing how to set up a static website for almost $0. We'll be talking about CloudFront CDNs, a bunch of stuff then as well. But let's see who's online this evening. Science and tech. Let's see. Why are you recommending me to myself? That seems really weird. Techno Tim. What projects are you working on? Let's I thought we raided Techno Tim a long time ago. Let's raid Techno Tim. Cool. Let's head over. Let's say hello. Thanks, everyone. Have a great night. Let me give you a countdown as soon as I type in Techno Tim here. But again, thank you. We're out of here in 10, 9, 8, 7, 6, 5, 4, 3, 2,
One, have a good night, everyone.